There is a moment just before full darkness settles over a clear night, when the sky does something remarkable. It opens, not in any dramatic way, not with sound or signal, but quietly, incrementally, the way a held breath is finally released. One star appears, then three, then dozens. Then, if you are far enough from the cities and their restless glow, the sky fills with light until it seems almost crowded, almost generous, almost as if the universe has arranged itself specifically to be witnessed. You stand beneath it and feel, without quite deciding to feel it, that you are surrounded, that the cosmos is abundant, that existence is everywhere. That feeling is one of the oldest and most persistent illusions in human experience, and this journey begins by following it, not to celebrate it but to watch it come apart. If you find yourself drawn to questions that don't resolve easily, to the kind of wonder that sits just at the edge of unease, then stay close to beyond the universe, where the further we travel from the familiar, the more the familiar stops making sense. While the conditions still exist for questions to be asked and answers to be found, subscribe to Beyond the Universe. Because the darkness is patient and the time we have to look is finite. Look up on a clear night and count what you can see. With the naked eye, under ideal conditions, you might distinguish somewhere between 2,000 and 5,000 individual stars. They appear scattered across the dome of the sky in every direction, some bright and close, some faint and distant, arranged in patterns that human cultures have been naming and narrating for tens of thousands of years. The sky looks populated. It looks like a place where things exist, and that impression is not entirely wrong. Those stars are real. Their light is real. The distances between them, though enormous by any human measure, are real distances within a real structure. The Milky Way, the galaxy that contains our sun and every star visible to the naked eye from Earth, is a genuine and staggering object. It spans roughly 100,000 light-years from edge to edge. It contains somewhere between 100 billion and 400 billion stars, depending on how you count and what you include. It is ancient, complex, layered with gas and dust and the remnants of stars that burned and died before our sun was born. By any reasonable standard, it is extraordinary. But the Milky Way is not the universe. It is not even a significant fraction of the universe. It is one structure among an estimated 2 trillion galaxies within the observable portion of the cosmos alone. 2 trillion. That number is so large it resists comprehension. And yet, it is the number that astronomers currently work with when they try to account for the visible matter in the universe. 2 trillion galaxies, each containing billions or hundreds of billions of stars, each star potentially orbited by worlds, each world potentially harboring conditions that could, in principle, support complexity. When you hold that number in your mind, the universe seems not just full but overflowing. It seems like a place so saturated with structure and light and possibility that emptiness would be the exception. The rare gap between one magnificent thing and the next. This is the illusion. And it is a powerful one, because it is built from real facts. The galaxies are real, the stars are real, the light is real, but the picture those facts paint when assembled in the human imagination is profoundly, almost deliberately misleading. Because what those numbers do not immediately communicate, what they quietly conceal behind their own enormity, is the scale of the spaces between them. Begin with something close. Begin with the space between stars inside our own galaxy. The nearest star to our sun is Proxima Centauri, a small red dwarf located approximately 4.24 light-years away. A light-year is the distance light travels in a single year, moving at roughly 300,000 kilometers per second. In 1 year, light covers about 9.46 trillion kilometers. Proxima Centauri is 4.24 of those years away. That means the gap between our sun and its nearest neighbor is approximately 40 trillion kilometers. If you were to shrink the sun to the size of a grapefruit and place it on a table, the nearest neighboring grapefruit on that same scale would be roughly 2,500 kilometers away. Not across the room, not across the city, across a continent, and that is the nearest one. Most stars in the Milky Way are separated by distances far greater than that. The Milky Way, for all its hundreds of billions of stars, is not a dense place. It is not a crowded room. It is a room so large that the objects inside it are separated by distances that make the objects themselves almost irrelevant to the total volume. If you were to take all the stars in the Milky Way and calculate what fraction of the galaxy's total volume they actually occupy, the answer would be so small it would be difficult to express meaningfully. Stars are points of light inside an architecture of near-total emptiness. The galaxy is not a solid thing, or even a loosely packed thing. It is a pattern of rare, isolated fires burning in a darkness so deep and so wide that the fires themselves are almost beside the point. But even this is not the full picture. Even the emptiness inside a galaxy is not the emptiness that defines the universe. To find that, you have to leave. You have to move outward, past the outer arms of the Milky Way, past the thin scattering of stars at the galaxy's edge, and into the space between galaxies. And when you do, something changes. Something in the quality of the darkness changes, because inside the Milky Way, even in its emptiest regions, you are still surrounded by the faint gravitational presence of hundreds of billions of stars. You are still inside something, but once you cross the threshold into intergalactic space, that sense of enclosure dissolves. The galaxy behind you becomes a shape, a disk of light growing smaller and more distant, and ahead of you, in every direction, there is almost nothing. The distance from the Milky Way to the Andromeda Galaxy, our nearest large galactic neighbor, is approximately 2.5 million light-years. 2.5 million years of light travel time separates these two structures, and Andromeda is close, cosmically speaking. It is close enough that the two galaxies are gravitationally bound to each other, part of a small collection of galaxies called the local group. But even within the local group, the distances between member galaxies are measured in millions of light-years. The space between them is not a brief corridor. It is an almost incomprehensible gulf of near-nothingness, a region where the density of matter drops to levels that would be considered a near-perfect vacuum by any laboratory standard on Earth. You are drifting now. Imagine it. You have left the Milky Way behind. It is still visible, a pale smear of light behind you, its spiral arms just barely distinguishable at this distance. Ahead, Andromeda glows faintly, a soft ellipse of accumulated starlight. Between you and it, there is nothing. No stars, no planets, no gas clouds dense enough to see. Just the faint, almost undetectable presence of a few stray hydrogen atoms per cubic meter, the residue of a universe that has been expanding and thinning for nearly 14 billion years. The silence here is not metaphorical. It is structural. It is the silence of a place where almost nothing has ever happened and almost nothing ever will. And this is where the first real shift in perception begins. Because when you are standing on Earth, looking up at a sky full of stars, the universe feels inhabited. It feels like a place where things are. But when you move outward, when you actually trace the distances and the densities and the proportions, a different picture assembles itself. The universe is not full of stars and galaxies the way a forest is full of trees. It is more like a handful of dust thrown into a cathedral. The dust is real. The particles are real. But the cathedral is so much larger than the dust that the dust barely registers against the total volume of the space it occupies. Consider the numbers more carefully. The observable universe, the portion of the cosmos from which light has had time to reach us in the roughly 13.8 billion years since the Big Bang, has a radius of approximately 46 billion light-years. That is not a typo. The observable universe extends 46 billion light-years in every direction from Earth, giving it a total diameter of about 93 billion light-years. Within that volume, as noted, there are an estimated 2 trillion galaxies. That sounds like a lot. But when you calculate the average density of matter in the universe, when you take all the stars and gas and dust and planets and everything else that can be detected and spread it evenly across that total volume, you get a number that is almost nothing. The average density of matter in the observable universe is roughly equivalent to a few hydrogen atoms per cubic meter, not per cubic centimeter, per cubic meter. A box 1 meter on each side, placed at a random location in the universe, would on average contain only a handful of individual atoms. The universe, taken as a whole, is not full. It is almost perfectly empty. This is not a poetic exaggeration. It is a physical description. The universe by volume is overwhelmingly, structurally, fundamentally empty. The matter that exists, the stars, the galaxies, the gas, the dust, the planets, the moons, the asteroids, everything that has ever been named or observed or imagined, occupies a fraction of the total volume so small that it barely qualifies as a rounding error in the cosmic accounting. Everything that has ever existed, every civilization that has ever risen and fallen, every thought that has ever been thought, every photon of light that has ever been emitted by any star in any galaxy, all of it together represents a thin, fragile, almost accidental scattering of structure inside a reality that is, at its core, defined by absence. But it gets worse, because even that description, the one that reduces all matter to a thin scattering, is still not fully honest about the nature of the emptiness, because the emptiness is not uniform. It is not a smooth, featureless void distributed evenly between the galaxies. The emptiness has structure, it has shape, and that shape, when you begin to understand it, is one of the most unsettling things that modern cosmology has revealed about the universe we inhabit. To understand this, you have to pull back further, much further. You have to rise above the scale of individual galaxies and even galaxy clusters, and look at the universe from a perspective so distant that individual galaxies become invisible, reduced to points of light too small to distinguish. At this scale, something remarkable becomes visible. The matter in the universe is not distributed randomly. It is not scattered like dust thrown into the air. It is arranged. It forms a pattern, a web, a network of thin filaments and dense nodes connected by threads of matter, surrounding enormous regions where almost nothing exists at all. Astronomers call this the cosmic web, and it is one of the largest known structures in the observable universe. The filaments of the cosmic web are made of galaxies and gas, strung together by gravity into long, thin threads that can stretch for hundreds of millions of light years. Where filaments intersect, matter accumulates into dense clusters, the most massive gravitationally bound structures in the universe, containing thousands of galaxies packed into a region that, while enormous by human standards, is compact by cosmic ones. But between the filaments, between the nodes and the threads, there are the voids. And the voids are not small. They are not gaps. They are not the spaces between things. They are the dominant feature of the cosmic web. They are the majority of the universe's volume. They are regions so large, so empty, so devoid of galaxies and gas and structure, that they make the emptiness between individual stars seem almost cozy by comparison. The Bode's void, one of the most studied large-scale voids in the observable universe, spans approximately 330 million light-years in diameter, 330 million light-years of space containing almost no galaxies, almost no stars, almost no light. A region so empty that when astronomers first mapped it in the 1980s, some of them reportedly joked that if the Milky Way had been located inside it, humanity would not have discovered other galaxies until the space age, because there would have been almost nothing to see. That joke contains a truth that is worth sitting with. The universe could have been arranged so that we were surrounded by nothing, and in a sense, for the civilizations that might exist inside the deepest voids, that is exactly the situation they face. But the Bode's void is not even the largest known void. Surveys of the large-scale structure of the universe have revealed voids that dwarf it, regions of near-total absence that stretch for hundreds of millions, or even over 1 billion light-years. These are not anomalies. They are not rare exceptions to a universe that is otherwise full. They are the rule. They are the dominant architecture. The filaments and clusters of the cosmic web are the exception. The thin lines of matter drawn around the edges of these enormous absences, the way frost forms on the edges of a window, tracing the boundary between warmth and cold without filling the glass. And here is the thing that the night sky does not tell you. Here is the thing that the apparent abundance of stars conceals. When you look up and see that crowded, luminous sky, you are seeing the inside of a filament. You are seeing the inside of one of those thin threads of matter in the cosmic web, a region that is, by cosmic standards, unusually dense. The Milky Way is not located in a typical part of the universe. It is located in a region where matter has accumulated, where gravity has drawn gas and stars and galaxies together into a structure that, from the inside, feels populated and rich. But step outside that filament, drift into the void beyond it, and the sky changes. The galaxies thin out, the light fades, the distances between things grow, until the concept of nearness loses its meaning entirely. This is the first layer of the contradiction. The universe appears full because we are standing in one of its rare dense regions, looking outward through a lens of accumulated matter that makes the cosmos seem more inhabited than it is. We are, in a sense, cosmically privileged in our location, not because the universe placed us here with intention, but because matter tends to cluster, and we are made of matter, and matter is where matter goes. But the privilege is narrow, it is local. It does not extend beyond the filament, beyond the cluster, beyond the thin thread of structure that we call home. Move outward from the Milky Way. Move past the local group, past the Virgo cluster, past the Laniakea supercluster, the enormous gravitational basin that contains our galaxy, and hundreds of thousands of others, stretching across roughly 500 million light-years. Move past all of that, and you begin to enter the voids. You begin to enter the regions where the cosmic web thins to almost nothing, where the filaments are so sparse and so distant from each other that the space between them is not a corridor, but a continent of darkness. And as you move through those regions, the light behind you, the accumulated glow of the Laniakea supercluster, the faint smear of the Milky Way, the distant points of the nearest galaxy clusters, begins to fade, not because anything has happened to the light, but because the distances have grown so large that the light is thinned to almost nothing, spread across a volume so enormous that even the combined output of hundreds of billions of stars becomes a whisper. There is a particular quality to this kind of distance that is difficult to convey. It is not the distance of a long road, where you know the destination exists and the journey is simply a matter of time and effort. It is the distance of a space where the concept of destination becomes uncertain, where the question of whether there is anything ahead of you is genuinely open, where the darkness is not a temporary condition between two lit places, but the default state of a universe that has spread its matter so thin that light is the exception and silence is the rule. And yet, even now, even at this scale, even in the deepest voids, the universe is not entirely empty. There are stray atoms. There are faint magnetic fields. There are the occasional rogue stars ejected from their galaxies by gravitational interactions and now drifting alone through intergalactic space, burning in a darkness so complete that their light reaches nothing, illuminates nothing, is witnessed by nothing. These stars exist. They fuse hydrogen into helium. They emit light in every direction, and that light travels outward into a void so large that it will never reach another star, never warm another world, never be absorbed by anything at all. It will simply travel forever, growing fainter with distance, until the expansion of the universe stretches its wavelength beyond any possible detection, and it becomes, for all practical purposes, as if it never existed. This is the universe, not the universe of the night sky, with its apparent generosity of light, not the universe of the astronomy textbook, with its catalog of magnificent objects, but the universe as it actually is, measured and mapped and understood as best as current science allows, a structure of almost incomprehensible scale, dominated by emptiness, organized around absence, populated by rare and isolated concentrations of matter that burn briefly against a darkness that was here before them and will remain long after they are gone. The night sky lied to you, not maliciously, not with intent, but the way all beautiful things lie, by showing you their best face, by presenting the part of themselves that is easiest to love and leaving the rest in shadow. The stars you see are real, but they are not representative. They are the highlights of a universe that is, in its totality, far darker, far emptier, and far more indifferent than the view from a clear night on Earth would ever suggest. And this is only the beginning. Because the emptiness of the universe is not simply a matter of scale, not simply a question of how much space exists between the things we can see. The emptiness goes deeper than that. It is woven into the structure of matter itself, into the nature of the forces that hold the universe together, and into the direction in which the universe appears to be moving. The emptiness is not a background condition. It is an active feature of reality. And understanding what it means, truly understanding it, not just as a number or a distance but as a fact about the nature of existence, requires going further, much further. For now, hold this image. You are somewhere between galaxies. Behind you, the Milky Way is a faint smudge of light, barely distinguishable from the other faint smudges scattered across the sky. Ahead of you, there is darkness. Not the darkness of a room with the lights off, where you know the walls are there and the furniture is there and the world is simply temporarily invisible. This is the darkness of a place where the walls are genuinely absent, where the furniture does not exist, where the world in any meaningful sense has not arrived and may never arrive. You are floating in a region of the universe where the average distance to the nearest galaxy is measured in millions of light years, where the nearest star is so far away that its light, traveling at the maximum speed the universe permits, would take longer than the entire history of human civilization to reach you. You are, by any reasonable definition, alone. Not alone in the way a person feels alone in a crowd, alone in the way that a single atom is alone in a cubic meter of vacuum. Structurally, fundamentally, as a matter of physical fact, this is where the journey begins. Not at the edge of the universe, not at the moment of its birth, not at the site of some dramatic cosmic event. It begins here, in the quiet, in the dark, in the space between things, where the universe reveals what it is actually made of. And what it is actually made of is not light, it is not matter, it is not energy, it is distance, it is separation, it is the gap between one thing and the next, a gap so large and so pervasive that everything else, every star, every galaxy, every atom, every thought, is just a brief interruption in an otherwise unbroken silence. The universe is not full, it never was. And the more carefully you look, the more clearly that truth comes into focus, like a shape emerging from fog, slowly, inevitably, until you can no longer pretend you did not see it. The shape is emptiness, and it is everywhere. But to understand how deep that emptiness goes, you cannot stay here, suspended between galaxies in the intergalactic dark. You have to go back. You have to return to the galaxies themselves, to those brilliant islands of light that seem, from a distance, so dense and so full of structure, because the galaxies are hiding something too. And what they are hiding is the same thing the universe is hiding, just at a smaller scale. The same emptiness, the same silence, the same fundamental absence dressed up in the appearance of abundance. A galaxy, seen from outside, is a beautiful object. The spiral arms of a galaxy like the Milky Way or Andromeda, photographed in long exposures by space telescopes, glow with the combined light of billions of stars threaded through with dark lanes of dust and lit from within by the blue-white fire of young, massive stars burning through their fuel at a furious rate. From a distance of millions of light years, a spiral galaxy looks almost solid. It looks like a thing you could hold, a disk of light with a bright center and graceful arms curving outward into space. It looks inhabited in the way a city looks inhabited from an airplane at night, a dense network of light suggesting density, activity, presence. But a city seen from an airplane is genuinely dense. The lights represent buildings and streets and people packed into a relatively small area. A galaxy is not like that. A galaxy is a city where the buildings are separated by hundreds of kilometers of empty space, where the streets are so wide that a car traveling at the speed of light would take years to cross them, where the population is so spread out that the concept of crowding becomes meaningless. The stars in a galaxy are not close to each other. They are not even close to each other by the standards of the emptiness between galaxies. They are simply less far apart than the galaxies themselves, and that distinction, less far apart rather than close, is one of the most important distinctions in understanding what the universe actually is. The space between stars inside the Milky Way is not empty in the way that intergalactic space is empty. There is gas, there is dust, there are magnetic fields and cosmic rays and the faint radiation left over from ancient stellar explosions. The interstellar medium, as astronomers call it, is a complex and dynamic environment, thin by any laboratory standard, but rich with structure compared to the void between galaxies. And yet, even within this relatively dense environment, the distances between individual stars are so enormous that the stars themselves are almost irrelevant to the total volume. The Milky Way is not a solid disk. It is not even a loosely packed disk. It is a pattern of rare, isolated points of light embedded in a medium that is, by any human measure, a near-perfect vacuum. And within each star, within each of those rare points of light, the same story repeats. Because a star is not a solid object either. A star is a sphere of plasma, a gas so hot that its electrons have been stripped from their atoms, held together by gravity, and kept from collapsing by the outward pressure of nuclear fusion at its core. The Sun, our nearest star, has a diameter of about 1.4 million kilometers. It is enormous by human standards. But even within the Sun, even within that roiling sphere of plasma, the atoms are not touching. They are not packed together. They are separated by distances that, at the atomic scale, are vast. And within each atom, the same emptiness persists. The nucleus of an atom occupies a tiny fraction of the atom's total volume. If an atom were scaled up to the size of a football stadium, the nucleus would be roughly the size of a marble at the center, and the electrons would be somewhere near the outer walls, and everything in between would be empty space. The emptiness goes all the way down. From the scale of the observable universe to the scale of the atom, the dominant feature of physical reality is not matter. It is space. It is absence. It is the gap between things. Matter is the exception. Emptiness is the rule. And this is not a philosophical observation or a poetic metaphor. It is a physical description of the universe as it actually exists, measured and confirmed by every instrument and every method that science has developed over the past several centuries. You are made of atoms, your body, your brain, the neurons firing as you process these words, the air moving through your lungs, the ground beneath your feet. All of it is made of atoms, and all of those atoms are almost entirely empty space. The matter that makes up your body, if compressed to remove all the empty space within and between its atoms, would fit into a volume far smaller than a grain of sand. The rest of you, the vast majority of the volume you occupy, is nothing, is space, is the same fundamental emptiness that separates galaxies and fills the voids between the filaments of the cosmic web. You are not a solid thing moving through an empty universe. You are a pattern of emptiness, briefly organized into a shape that can ask questions about the emptiness surrounding it. This is the first revelation, Not that the universe is large, that much was known, or at least suspected for a long time, but that the universe is empty in a way that is not incidental, not accidental, not a side effect of its size. The emptiness is the primary fact. The matter is the secondary fact. And the matter, for all its complexity and beauty and capacity to organize itself into stars and galaxies and living things, is a thin, fragile, temporary interruption in a reality that was empty before it arrived and will be empty long after it is gone. The night sky with all its stars is not a window into a full universe. It is a window into the nearest filament of the cosmic web, the local concentration of matter that happens to surround the particular point in space where Earth formed and life arose. Step outside that filament, and the sky empties. Step outside the local group and the nearest galaxies become faint smudges separated by distances that make the word neighbor feel like a cruel joke. Step into the voids and the sky becomes almost blank, a darkness so complete and so vast that the concept of a populated universe begins to feel like a story told by creatures too small and too brief to see the whole picture. And the whole picture is this: the universe is overwhelmingly nothing. It is a near-perfect vacuum, punctuated by rare concentrations of matter that burn for a while and then go dark. It is a structure built around absence, organized by forces that do not care about the matter they move, shaped by a history that did not require life or consciousness or meaning to unfold. It is beautiful, in the way that a desert is beautiful, in the way that silence is beautiful, in the way that things are beautiful when they are honest about what they are, but it is not full, it is not warm, it is not built for us. And the further you travel from the comfortable illusion of the night sky, the more clearly that truth becomes visible, rising out of the darkness like a shape that was always there, waiting to be seen. Return now to the galaxies. Return to those brilliant islands of light, because there is something about them that has not yet been said, something that the long view from outside their borders conceals. When you look at a galaxy from a distance of millions of light years, you see light. You see the accumulated glow of billions of stars, the blue shimmer of young stellar nurseries, the warm gold of older stellar populations, the faint red haze of hydrogen gas being ionized by radiation. You see structure. You see arms and cores and halos and the suggestion of motion, of rotation, of a system that is doing something that is alive in some mechanical sense, that is not simply sitting still in the dark. And all of that is real. But it is also, in a very precise way, a kind of theater, a performance of density that the galaxy does not actually possess. Think about what a galaxy actually is, not as an image in a telescope, but as a physical object in space. The Milky Way, for example, is a disk of stars and gas roughly 100,000 light-years across and perhaps 1,000 light-years thick at its outer edges, thickening toward the central bulge. Within that disk, there are somewhere between 100 billion and 400 billion stars. That sounds like an enormous number of objects packed into a defined space. But the disk is not small. 100,000 light-years across, 1,000 light-years thick. The volume of that disk is staggering, and the stars inside it, for all their number, are separated by distances that average several light-years each. The disk is not dense. It is not packed. It is a thin, flat structure of isolated fires separated by years of light travel time, embedded in a medium of gas and dust that is itself so thin it would qualify as a hard vacuum by any standard achievable in a laboratory on Earth. And the disk is not even the whole galaxy. Around the disk, extending far above and below the plane of the Milky Way, there is the halo, a vast, roughly spherical region of space that contains older stars, globular clusters, and something else, something that cannot be seen directly, something that reveals itself only through its gravitational effects on the matter around it. The halo extends for hundreds of thousands of light-years in every direction, dwarfing the disk in volume, and it is even emptier than the disk. The stars in the halo are sparse, ancient, scattered across a volume so large that the halo itself is more absence than presence. And yet the halo is there, and it matters, because the halo is where the first hints of a deeper mystery begin to surface. For decades, astronomers studying the rotation of galaxies noticed something that did not fit. When you observe a spiral galaxy rotating, when you measure the speed at which stars at different distances from the galactic center are orbiting, you expect to find a particular pattern. You expect the stars near the center, where most of the visible mass is concentrated, to orbit quickly, and the stars at the outer edges, far from the center, to orbit more slowly. This is what physics predicts. This is what happens in our solar system, where the inner planets orbit the sun faster than the outer ones. It is a straightforward consequence of gravity. The further you are from the source of gravitational pull, the less pull you feel and the slower your orbit. But galaxies do not behave this way. When astronomers measured the orbital velocities of stars at different distances from galactic centers, they found that the outer stars were moving far too fast, not slightly too fast, dramatically too fast. Fast enough that if the only gravity acting on them came from the visible matter in the galaxy, the stars, the gas, the dust, those outer stars should have been flung out of the galaxy long ago. They should not be there, and yet they are. Galaxy after galaxy, the same pattern appears. The rotation curves, as astronomers call them, are flat where they should decline. The outer regions of galaxies are moving as if they are embedded in a much larger gravitational field than the visible matter can account for. The explanation that has emerged from decades of observation and modeling is one of the most unsettling ideas in modern cosmology. The visible matter in a galaxy, everything that emits or reflects light, everything that can be directly detected, may account for only a fraction of the total mass. The rest, the majority of the mass, may be made of something that does not interact with light at all, something that does not emit it, does not absorb it, does not reflect it, something that is, in the most literal sense, invisible. Astronomers call it dark matter, and while its exact nature remains one of the deepest unsolved problems in physics, its gravitational effects appear to be real, consistent, and pervasive. Dark matter, if the current models are correct, does not clump into stars or planets. It does not form disks or spiral arms. It does not radiate energy or cool down or collapse into compact objects the way ordinary matter does. Instead, it appears to exist in vast, diffuse halos surrounding and interpenetrating galaxies, extending far beyond the visible edges of the stellar disk, providing the gravitational scaffolding that holds the galaxy together and shapes its rotation. The dark matter halo of the Milky Way may extend for 1,000,000 light-years or more in every direction, a sphere of invisible mass so large that the luminous galaxy at its center is just a small, bright core inside a much larger, invisible structure. And this changes the picture of the galaxy in a profound way, because if dark matter is real, then the galaxy you see, the disk of stars and gas, the spiral arms, the glowing core, is not the galaxy. It is the visible part of the galaxy. It is the luminous fraction of a much larger object, most of which is made of something that cannot be seen, cannot be touched, cannot be directly detected by any instrument currently in existence. The galaxy is an iceberg, and the stars are the tip. The vast, dark, invisible bulk extends far beyond what any telescope can show, shaping the motion of everything inside it without revealing itself. But it goes deeper, because dark matter is not just a property of individual galaxies. It appears to be a fundamental component of the universe's large-scale structure. The cosmic web, those filaments and nodes and voids that define the architecture of the observable universe, appears to have been shaped, at least in part, by dark matter. In the early universe, shortly after the Big Bang, the distribution of matter was almost perfectly uniform. Almost, but not quite. There were tiny fluctuations, regions where the density of matter was slightly higher than average, and regions where it was slightly lower. Over time, gravity amplified these fluctuations. The denser regions attracted more matter, growing denser still. The less dense regions lost matter to their neighbors, growing emptier. And the dark matter, which interacts gravitationally but not electromagnetically, may have been the first component of the universe to begin this process of gravitational collapse, forming the invisible skeleton around which ordinary matter later accumulated. In this picture, the cosmic web is not primarily a structure of stars and gas. It is primarily a structure of dark matter, a vast invisible network of filaments and halos, and the galaxies we see are simply the places where ordinary matter has fallen into the gravitational wells created by that invisible network. The luminous universe, everything that can be seen, is a kind of tracing paper laid over a much larger invisible architecture. The real structure is dark, the real skeleton is hidden, and the galaxies, for all their beauty and complexity, are just the glowing residue of a process driven by something that has never been directly observed. This is a deeply strange idea. It means that the universe we can see, the universe of stars and galaxies and nebulae and light, is not the dominant form of matter in the cosmos. Ordinary matter, the kind made of protons and neutrons and electrons, the kind that makes up stars and planets and people, accounts for only about 5% of the total energy content of the observable universe. 5%. The rest is divided between dark matter, which accounts for roughly 27%, and something even more mysterious, something that does not behave like matter at all, which accounts for the remaining 68%. That something is called dark energy, and it is, in many ways, the most disturbing discovery in the history of cosmology. But before arriving at dark energy, stay for a moment with the implications of dark matter. Stay with the idea that the universe you can see is not the universe that exists, that the visible cosmos, the 2 trillion galaxies, the hundreds of billions of stars per galaxy, the light that has been traveling for billions of years to reach your eyes, is a minority, a small luminous fraction of a much larger reality that is, by its nature, invisible, that the universe is not just empty in the spaces between galaxies, it is also, in a sense, empty of the kind of matter that can be known directly. The majority of the universe's mass is made of something that has never been held, never been measured in a laboratory, never been directly detected by any instrument. It is inferred from its effects, from the way it bends light and shapes rotation curves and influences the large-scale structure of the cosmos. It is known only by what it does to the things around it, never by what it is in itself. There is something philosophically vertiginous about this. The universe is not just larger than it appears, it is more than it appears. It contains more than can be seen, more than can be directly measured, more than can be fully known with the tools currently available, and the part that cannot be seen, cannot be measured, cannot be fully known, is the majority. The visible universe is the exception, the dark universe is the rule, and the dark universe is, almost by definition, a universe of absence, of things that are there without being present, of mass without light, of structure without visibility. You are drifting again. You have moved beyond the Milky Way, beyond the local group, beyond the Virgo cluster. You are somewhere in the middle distance of the cosmic web, in a region where the filaments are visible as faint threads of light against the darkness, where the voids between them are so large that the filaments themselves look thin and fragile, like cracks in a dark surface. And you are aware now that what you are seeing is not the whole picture, that the filaments you can see are embedded in a much larger structure of dark matter that you cannot see, that the voids between the filaments are not simply empty but are regions where even the dark matter is sparse, where the invisible skeleton of the universe has thinned to almost nothing. The emptiness is not just the absence of light, it is the absence of almost everything. The voids of the cosmic web are not simply large, they are, in a very real sense, the dominant feature of the universe. When cosmologists map the large-scale structure of the observable universe, what they find is that the majority of the volume is occupied by voids. The filaments and clusters and walls of the cosmic web, for all their visual prominence in maps of the universe, occupy only a small fraction of the total volume. The voids occupy the rest, and the voids are not uniform. They have their own internal structure, their own subtle variations in density, their own faint populations of galaxies that manage to form even in the near absence of matter. But they are, by any reasonable measure, empty. They are regions where the density of matter, both visible and dark, is far below the cosmic average, where galaxies are rare and isolated, where the distances between things are so large that the concept of a neighborhood becomes meaningless. The Bode's void mentioned earlier is one of the most studied of these structures, but it is worth returning to it, because its scale is genuinely difficult to absorb. 330 million light-years in diameter. If you were to place the Milky Way at the center of the Bode's void, the nearest galaxy cluster would be so far away that its light, traveling at the speed of light, would take over 100 million years to reach you. The night sky from inside the Bode's void would be almost blank, not dark in the way our night sky is dark, with its thousands of visible stars and its faint band of the Milky Way, dark in a more fundamental way, dark in the way that a universe with almost no galaxies within reach would be dark. A few faint smudges of light at the very edge of visibility, separated by distances so enormous that the word isolated does not begin to capture the situation. And yet even the Bode's void is not the largest known void. Surveys of the universe's large-scale structure have revealed structures called supervoids, regions of below-average density that can span over 1 billion light-years. The cold spot in the cosmic microwave background radiation, a region of the sky that appears slightly cooler than its surroundings in the oldest light in the universe, may be associated with a supervoid of extraordinary scale, a region where the density of matter is so low that photons traveling through it lose a small but measurable amount of energy, leaving a faint imprint on the oldest light in the cosmos. The universe's emptiness is not just a feature of the present, it is written into the oldest record of the universe's history, imprinted on the light that has been traveling since the universe was less than 400,000 years old. This is the architecture of absence. This is what the universe looks like when you step back far enough to see the whole pattern, Not a cosmos full of galaxies and light, but a vast, mostly empty structure, organized around regions of near total absence, with matter clinging to the edges of those absences in thin, fragile threads. The matter is real, the light is real, but the emptiness is more real, in the sense that it is more prevalent, more pervasive, more fundamental to the shape of the universe than any of the luminous structures that inhabit it. And this emptiness is not static. It is not a fixed condition, a permanent feature of a universe that has settled into its final form. The universe is changing. It has been changing since the moment of its birth, and the direction of that change is, in many ways, the most disturbing aspect of the whole picture. Because the universe is not simply empty, it is becoming more empty. The distances between things are not fixed. They are growing, and the rate at which they are growing is not constant. It is accelerating. To understand this, you have to understand something about the nature of cosmic expansion that is easy to misstate and easy to misunderstand. When astronomers say that the universe is expanding, they do not mean that the galaxies are moving through space, flying outward from some central point like shrapnel from an explosion. The universe does not have a center in that sense. There is no point in space from which everything is moving away. Instead, what is happening is something more subtle and more unsettling. Space itself is expanding. The fabric of the cosmos, the medium in which galaxies and stars and everything else exist, is stretching. The distances between galaxies are increasing, not because the galaxies are moving through space, but because the space between them is growing. This distinction matters enormously. If galaxies were simply moving through space, then the expansion of the universe would be something that could, in principle, be reversed. Gravity could slow the galaxies down, stop them, pull them back together. And for most of the 20th century, this was the expectation. The universe was expanding, yes, but gravity was slowing the expansion. And the question was simply whether there was enough matter to eventually halt the expansion and reverse it, or whether the universe would expand forever, slowly decelerating but never quite stopping. It was a question with two possible answers, and both of them were, in a sense, comprehensible. Either the universe collapses back on itself in a big crunch, or it expands forever, growing colder and emptier, but at least doing so at a decreasing rate. Then, in 1998, two independent teams of astronomers studying distant supernovae made a discovery that overturned this picture entirely. They were using a particular type of supernova, the explosion of a white dwarf star that has accumulated enough mass to trigger a runaway nuclear reaction, as a standard candle, a light source of known intrinsic brightness that could be used to measure cosmic distances. By comparing the apparent brightness of these supernovae with their expected brightness, the astronomers could calculate how far away they were. And by measuring the redshift of their light, the stretching of their wavelengths caused by the expansion of the universe, they could determine how fast the universe was expanding at the time the light was emitted. What they found was not what anyone expected. The distant supernovae were fainter than they should have been. They were further away than the models predicted. And the only explanation that fit the data was one that seemed at first almost impossible. The expansion of the universe was not slowing down. It was speeding up. The universe was not decelerating under the influence of gravity. It was accelerating. Something was pushing the universe apart, overcoming the gravitational attraction of all the matter in the cosmos and driving the expansion faster and faster with time. That something has been given the name dark energy. And it is, in many ways, the most mysterious and most disturbing concept in modern cosmology. Dark energy is not a substance in the ordinary sense. It does not clump. It does not form structures. It does not interact with matter or light in any way that has been directly detected. It appears to be a property of space itself, an energy density that is intrinsic to the vacuum, that does not dilute as the universe expands, but remains constant, or nearly constant, per unit volume of space. As the universe expands and the volume of space increases, the total amount of dark energy increases with it, and its repulsive effect grows stronger, driving the expansion faster and faster in a self-reinforcing cycle. The implications of this are staggering. If dark energy continues to behave as current observations suggest, the expansion of the universe will not slow down. It will not stop. It will accelerate indefinitely, driving galaxies further and further apart, stretching the space between them until the distances become so large that light can no longer bridge them. There is a concept in cosmology called the cosmic event horizon, the boundary beyond which light emitted today will never reach us, because the expansion of space will carry those regions away faster than the light can travel. Everything beyond that horizon is, in a very real sense, permanently beyond reach. Not just far away, not just difficult to observe, causally disconnected, gone, in the only sense that matters for any observer inside the universe. And the cosmic event horizon is not a fixed boundary. It is shrinking. As the expansion accelerates, the region of the universe that is causally connected to any given observer becomes smaller over time. Galaxies that are currently observable, galaxies whose light is reaching us right now, will eventually cross the horizon and disappear, not because they have been destroyed, not because anything has happened to them, but because the space between us and them will have expanded so much that their light can no longer reach us. They will continue to exist, burning their stars, evolving their structures, perhaps harboring life and civilizations and histories of their own. But they will be, from our perspective, as if they never existed. Their light will redshift into invisibility. Their signals will fade below any possible threshold of detection, and the universe, as seen from any point within it, will appear to shrink. This is one of the most quietly horrifying ideas in all of cosmology, not because it involves destruction or violence or sudden catastrophe, but because it involves a kind of cosmic loneliness that has no remedy. The universe is not just empty now, it is becoming more empty, in the sense that the observable universe, the region that any observer can in principle see and interact with, is contracting. The total universe may be vast, may contain countless galaxies and structures beyond our current horizon, but the accessible universe, the universe that can be known and reached and communicated with, is shrinking, and it will continue to shrink, slowly at first, then faster, as the acceleration of expansion carries more and more of the cosmos beyond the reach of any signal, any light, any connection. Future observers, living in the far future of a universe dominated by dark energy, will look out at a sky that appears almost empty, not because the universe has become empty, but because the expansion will have carried most of the universe beyond their horizon. The galaxies that are currently visible to us, the 2 trillion galaxies of the observable universe, will, in the far future, have mostly receded beyond the event horizon of any observer in our local group. What will remain visible will be only the galaxies of the local group itself, the small collection of galaxies gravitationally bound to the Milky Way and Andromeda, which will by then have merged into a single large elliptical galaxy. Everything else will be gone, not destroyed, just unreachable, just beyond the horizon, existing in a universe that has become, for all practical purposes, invisible. Those future observers, if they exist, will have no way of knowing what we know now. They will look out at their sky and see a single large galaxy surrounded by darkness. They will have no evidence of the cosmic web, no evidence of the 2 trillion galaxies that once populated the observable universe, no evidence of the large-scale structure that took billions of years to form. The universe will appear to them as a single island of light in an infinite darkness, and they will have no way of knowing that it was ever anything else. The evidence will have been erased, not by destruction, but by distance, not by fire, but by the quiet, relentless expansion of space. This is a thought that deserves to be held carefully. We exist at a particular moment in the history of the universe, a moment when the observable universe is still large enough to reveal its own structure, when the cosmic web is still visible, when the evidence of the Big Bang is still detectable in the cosmic microwave background radiation, when the expansion of the universe can still be measured and its history reconstructed. We exist at a moment when the universe is still, in a sense, legible, when its past is still written in the light that surrounds us. But that legibility is temporary. It is a feature of this particular epoch, not a permanent property of the cosmos. In the far future, the universe will become less legible, then illegible, then silent. The evidence will fade, the connections will sever, and whatever observers exist in that future will be left with a universe that appears by every available measurement to be a single isolated structure in an infinite void. But this future is not as distant as it might seem. The acceleration of expansion is already underway. It has been underway for roughly 5 billion years, since dark energy began to dominate the energy budget of the universe. And while the effects on the observable universe are not yet dramatic, the galaxies are still there, the cosmic web is still visible, the evidence of the universe's history is still accessible, the direction is clear. The universe is moving toward greater isolation, greater emptiness, greater silence. And it is doing so not slowly and reluctantly, but with an acceleration that suggests the process will only intensify with time. There is something in this that resists easy acceptance. The human mind is built for a world of connections, of relationships, of things that persist and can be returned to. The idea that the universe is structured in a way that systematically severs connections, that the fundamental dynamics of the cosmos work against the persistence of relationships and the accumulation of knowledge, is deeply counterintuitive. It feels wrong. It feels like a mistake, like a misreading of the evidence. But the evidence is consistent. The expansion is real. The acceleration is real. The horizon is real. And the direction of the universe, as best as current science can determine, is toward greater and greater isolation. Return now to the cosmic web. Return to that image of filaments and voids, of matter arranged in thin threads around enormous regions of absence, and add to that image the knowledge of dark matter and dark energy. The filaments are not just made of visible matter. They are embedded in halos of dark matter, invisible gravitational structures that extend far beyond the luminous galaxies. The voids are not just empty of visible matter. They are also depleted of dark matter, regions where even the invisible skeleton of the universe is thin and sparse. And the whole structure, filaments, voids, clusters, halos, is embedded in a universe that is expanding, accelerating, stretching the distances between everything, slowly pulling the filaments apart, slowly enlarging the voids, slowly moving every part of the cosmic web further from every other part. The cosmic web is not a permanent structure. It is a snapshot of a universe in transition, a moment in the long history of a cosmos that began in near-perfect uniformity, developed structure through the action of gravity and dark matter, and is now being slowly pulled apart by the action of dark energy. The structure that exists today, the filaments, the clusters, the walls, the voids, is the product of billions of years of gravitational assembly, and it is already beginning to be undone by billions of years of accelerating expansion. The universe built something, and now it is taking it apart, not violently, not suddenly, but steadily, relentlessly, in the way that a tide erases a sandcastle, not by attacking it, but simply by being what it is. And within the voids, within those enormous regions of near-total absence, the process is already complete. The voids are not becoming empty. They already are empty. They are the future of the universe, written in the present. They are what the universe looks like when expansion has done its work, when matter has been drawn away into the surrounding filaments, when the dark matter has thinned to near nothing, when the space has been stretched until the distances between things are so large that the things themselves become irrelevant. The voids are not gaps in the universe. They are previews of it. Drift into one of them. Drift into the interior of a void, away from the faint filaments at its edges, into the deep center where the density of matter is lowest and the distances are greatest. The filaments behind you are barely visible now, thin threads of faint light at the very edge of perception. Ahead of you in every direction there is darkness, not the darkness of space between stars, where the galaxy is still present as a gravitational context, a sense of belonging to something larger. This is a different darkness, a darkness that has no center, no edge, no nearby structure to orient yourself by. A darkness that is, in the most literal sense, the absence of almost everything. In this place, the universe reveals what it is at its most fundamental. Not a cosmos of stars and galaxies and light and complexity, but a cosmos of distance, of separation, of the space between things growing larger while the things themselves remain fixed in their isolation. The universe is not a place where things come together. It is a place where things move apart. Gravity creates local exceptions, temporary concentrations of matter that burn and glow and sometimes give rise to complexity. But the overall direction, the direction written into the expansion and the acceleration and the geometry of the cosmic web, is outward, always further, always more alone. And this is not a recent development. This is not a late-stage property of an aging universe. The expansion has been present since the beginning, since the first moments after the Big Bang, when the universe was a hot, dense, nearly uniform plasma, and the seeds of all future structure were already encoded in the tiny fluctuations of that primordial state. The universe was always going to expand. It was always going to thin. The matter was always going to cluster into filaments and leave voids behind. The dark energy was always going to accelerate the expansion. The horizons were always going to shrink. The isolation was always going to deepen. This is not a tragedy that befell the universe. It is the universe. It is what the universe is, and what it has always been moving toward. The question that this raises, the question that sits at the center of everything that has been described so far, is not a scientific question. It is a philosophical one. What does it mean to exist in a universe like this? What does it mean to be a structure of matter, briefly organized into a form capable of awareness and reflection, inside a cosmos that is overwhelmingly empty, that is becoming more empty, that is structured around absence, that is moving toward a future of greater and greater isolation and silence. What does it mean to look up at the night sky and feel wonder, when the night sky is a narrow window into a local concentration of matter inside a universe that is, in its totality, almost nothing? There is no comfortable answer to this question. There is no framework that makes it easy, no perspective that dissolves the unease. The universe does not provide one. The universe does not provide anything, in the sense of intention or purpose or design. It simply is what it is. A vast, mostly empty, expanding, accelerating structure of matter and energy and dark matter and dark energy, organized by forces that do not care about the matter they move, moving in a direction that does not favor the persistence of complexity or the accumulation of meaning. It is not hostile. It is not cruel. It is indifferent in a way that is more unsettling than hostility, because hostility at least implies a relationship. Indifference implies the absence of one. And yet, here you are. Here we are, existing inside this universe made of its matter, shaped by its forces, capable of asking questions about it that it cannot answer. The atoms in your body were forged in the cores of stars that lived and died before the sun was born. The carbon in your cells was scattered across space by stellar explosions and gathered by gravity into the cloud that became the solar system. You are, in the most literal sense, a product of the universe's brief experiment with complexity, a temporary arrangement of matter that has achieved the remarkable and perhaps unique ability to look back at the universe and ask what it is. But the universe is not asking the same question about you. The universe is not watching. It is not waiting. It is not curious about what you will discover or what you will build or what you will become. It is expanding. It is cooling. It is moving slowly and inexorably toward a future in which the structures that currently exist, the galaxies, the stars, the planets, the living things, will be gone, not by catastrophe, but by the quiet, patient action of entropy and expansion and the long cooling of a universe that is running out of the gradients that make complexity possible. That future is not imminent. The stars will burn for billions of years. The galaxies will persist for billions more. The universe is not ending soon by any human measure of time, but the direction is set. The trajectory is clear. And understanding that trajectory, understanding where the universe is going and why, requires going further into the darkness, further into the science of what happens when the expansion continues and the stars begin to fade, and the last sources of usable energy are exhausted. It requires following the universe to its end, or at least to the end of everything that currently makes it recognizable as a place where things exist. That journey begins with a single, quiet, deeply unsettling fact. The universe is not just empty, it is becoming more empty. And the process by which it is becoming more empty is not a sudden event or a dramatic transition. It is a slow, continuous, irreversible drift toward a state in which the distances between things are so large, and the energy available to bridge those distances so small, that the universe becomes, for all practical purposes, a place where nothing can happen, a place where the last structures have faded, the last light has been emitted, the last connection has been severed, and the silence that was always the dominant feature of the cosmos has finally, completely and permanently won. There is a word that physicists use when they want to describe the direction in which the universe moves. Not the direction of expansion, not the direction of any particular galaxy or particle, but the underlying direction of all physical processes, the arrow that points from one state of the universe to the next. The word is entropy, and it is, in the context of everything that has been described so far, the final piece of the picture, the piece that connects the emptiness of space to the fate of time itself. Entropy is not a simple concept, and it is frequently misunderstood. It is often described as disorder, as the tendency of systems to become more chaotic, more random, more mixed. And that description is not wrong exactly, but it misses something important. Entropy is better understood as the measure of how many ways a system can be arranged without changing its overall properties. A highly ordered system, a crystal, a living cell, a star in the process of fusing hydrogen, has low entropy because there are relatively few arrangements of its components that would produce the same overall structure. A disordered system, a gas dispersed evenly through a container, a cloud of particles spread uniformly through space, has high entropy because there are an enormous number of arrangements that would produce the same featureless uniformity. And the second law of thermodynamics, one of the most robust and universal laws in all of physics, states that in any closed system, entropy tends to increase over time. Order tends to give way to disorder. Gradients tend to flatten. Differences tend to dissolve. The universe, left to itself, moves from states of lower entropy to states of higher entropy, from structure to uniformity, from complexity to simplicity, from the particular to the general. This law is not a suggestion. It is not a tendency that can be overcome with sufficient effort or ingenuity. It is a statistical inevitability, a consequence of the fact that there are vastly more ways for a system to be disordered than ordered, and that physical processes, operating without direction or intention, will almost always move toward the more probable state. The universe is not moving toward entropy because something is pushing it there. It is moving toward entropy because entropy is where the overwhelming majority of possible states lie. Order is rare, disorder is common, and time, in the physical sense, is the direction in which the universe moves from the rare toward the common. But entropy, in the context of the universe, is not just about disorder in the abstract. It is about the availability of energy. It is about the difference between energy that can do work and energy that cannot. A hot object and a cold object placed in contact will exchange heat until they reach the same temperature. At that point, no more work can be extracted from the temperature difference, because the difference no longer exists. The energy is still there, conserved as the laws of physics require, but it is no longer available. It has been spread evenly, equilibrated, rendered useless for any process that requires a gradient to function. This is what physicists call thermal equilibrium, and it is, in a very real sense, the death of a system, not the destruction of its energy, but the loss of its capacity to do anything with that energy. Now scale this up. Scale it up to the size of the universe. The universe, in its current state, is far from thermal equilibrium. It contains hot things and cold things, dense regions and empty regions, stars burning at millions of degrees, and the cosmic background radiation cooling toward absolute zero. These differences, these gradients, are what make the universe interesting. They are what make stars shine and planets form and chemistry happen and life arise. The universe is interesting precisely because it is not in equilibrium, because it contains contrasts and differences and the flow of energy from high concentration regions to low concentration regions. But the second law of thermodynamics does not care about interest. It does not care about complexity or life or meaning. It simply states that the gradients will flatten, the differences will dissolve, and the universe will move, inexorably and without exception, toward a state of greater and greater uniformity. The question is not whether this will happen. The question is how long it will take and what the universe will look like as it happens. And the answer, as best as current physics can determine, is that the process will take an almost incomprehensibly long time, but that it will happen. Every star will eventually exhaust its fuel. Every galaxy will eventually lose its capacity to form new stars. Every black hole will eventually evaporate through a quantum process called Hawking radiation. Every particle of matter may eventually decay. And when all of this has happened, when the last gradient has flattened and the last source of usable energy has been exhausted, the universe will reach a state that physicists call the heat death, a condition of maximum entropy, minimum usable energy, and complete, permanent, irreversible equilibrium. The heat death of the universe is not a dramatic event. It is not an explosion or a collapse or a sudden transition. It is the absence of events. It is the state in which nothing happens, not because something has prevented events from occurring, but because there is no longer any energy gradient to drive them. It is the universe at rest, not in the sense of stillness, but in the sense of sameness. A universe in which every point is indistinguishable from every other point, in which the temperature is the same everywhere, in which the density is the same everywhere, in which there is no structure, no contrast, no difference, no information, no memory of anything that came before. It is the universe as a featureless, infinite, cold, dark, perfectly uniform expanse of near nothingness, in which the laws of physics still apply but have nothing left to act on. This is the end that the universe appears to be moving toward. Not the end of matter, not the end of space, not the end of time in any absolute sense, but the end of everything that makes the universe recognizable as a place where things happen. The end of stars, the end of light, the end of chemistry, the end of complexity, the end of the possibility of life, or thought, or memory, or meaning. The universe will not be destroyed. It will simply become, in every practical sense, empty. Not empty of space, but empty of difference. Empty of the contrasts that make existence possible. Empty of everything except the cold, dark, uniform residue of a cosmos that once contained stars and galaxies and living things and questions about its own nature. But the heat death is not the only possible fate, and it is worth pausing here to acknowledge the uncertainty. The behavior of dark energy over cosmic timescales is not fully understood. If dark energy is truly a cosmological constant, a fixed property of space that does not change with time, then the universe will expand forever, cooling and thinning toward the heat death. But if dark energy is something more dynamic, something that changes over time, the fate of the universe could be different. Some models suggest that dark energy could grow stronger over time, eventually becoming so powerful that it tears apart not just the large-scale structure of the universe, but galaxies, then solar systems, then planets, then atoms themselves, in an event called the Big Rip. Other models suggest that dark energy could weaken or even reverse, leading to a recollapse. The honest answer is that the ultimate fate of the universe depends on the nature of dark energy, and the nature of dark energy is not yet known. What is known is the direction: outward, cooling, thinning, separating. The details of the ending remain uncertain. The direction does not. Set aside the uncertainty for a moment and follow the most likely trajectory, the one that current observations most strongly support. The universe continues to expand, accelerating under the influence of dark energy. The galaxies beyond the local group recede beyond the cosmic horizon, one by one, over timescales of tens of billions of years. The local group itself, gravitationally bound, does not expand. The Milky Way and Andromeda continue their slow approach and eventually merge, billions of years from now, into a single large elliptical galaxy. This merged galaxy, sometimes called Milkomeda in informal discussions, becomes the last visible structure in the observable universe of any future observer within it. Everything else is gone, not destroyed, just beyond reach. Inside Milkomeda, the stars continue to burn, but the rate of star formation slows. The gas that fuels the birth of new stars is gradually consumed, and the supply of fresh gas from outside the galaxy has been cut off by the expansion that has isolated the local group from the rest of the universe. The galaxy ages. The most massive stars, which burn brightest and fastest, die first, in spectacular explosions that scatter their material back into the interstellar medium. The medium-mass stars, like the Sun, burn for billions of years and then swell into red giants before shedding their outer layers and leaving behind dense cooling remnants called white dwarfs. The smallest stars, the red dwarfs, burn so slowly and so dimly that they persist for trillions of years, long after every other type of star has gone dark. But even they, eventually, exhaust their fuel. Even they, eventually, go cold. The timescales involved in this process are difficult to convey. The current age of the universe is approximately 13.8 billion years. The Sun will exhaust its hydrogen fuel in roughly another 5 billion years. The last red dwarf stars will burn out in approximately 100 trillion years, roughly 10,000 times the current age of the universe. After that, the galaxy will be populated not by burning stars but by their remnants. White dwarfs slowly cooling toward the temperature of the surrounding space, neutron stars spinning in the dark, black holes consuming whatever matter drifts close enough to fall within their gravitational reach. The galaxy will still exist in a structural sense. It will still be a gravitationally bound collection of objects, but it will be dark. It will be cold. It will be a graveyard of stellar remnants drifting through a space that has not seen new starlight in longer than the current age of the universe. And it gets worse, because even the remnants are not permanent. White dwarfs, left to cool for long enough, will eventually reach the temperature of the surrounding space and become what are called black dwarfs, cold, dark, inert spheres of crystallized matter, invisible against the darkness of space. The timescale for this cooling is so long that no black dwarfs are thought to exist yet in the current universe. The universe is not old enough, but given sufficient time, they will form, and they will persist, cold and dark and silent, for timescales that dwarf even the era of the red dwarfs. Neutron stars will persist even longer, their interiors locked in a state of extreme density that resists further collapse. But they too will eventually interact with other objects, merge, or be consumed by black holes. And the black holes themselves, the most durable structures in the universe, are not permanent either. Stephen Hawking's theoretical work in the 1970s suggested that black holes slowly lose mass through a quantum process, emitting a faint trickle of radiation as virtual particle pairs near the event horizon are separated by the black hole's gravity, with one particle falling in and the other escaping. This process, called Hawking radiation, is so slow for large black holes that it is completely negligible on any timescale relevant to the current universe. But given enough time, even the most massive black holes will evaporate. The supermassive black hole at the center of Milkomeda, millions or billions of times the mass of the Sun, will eventually radiate away its last quantum of energy and disappear, leaving behind nothing but a faint burst of radiation that disperses into the surrounding space. The timescale for the evaporation of a supermassive black hole is staggering. It is measured not in billions or trillions of years, but in numbers so large that they require scientific notation to express, numbers with more digits than there are atoms in the observable universe. But the point is not the number, the point is the direction. The point is that even the most durable structures in the universe, the objects that survive the death of stars and the cooling of galaxies, and the isolation imposed by cosmic expansion, are not permanent. They are temporary. They are structures that exist for a while and then cease to exist, not because something destroys them, but because the laws of physics, operating over sufficient time, dissolve them. After the last black hole has evaporated, what remains? This is a question that physics can only partially answer, because the conditions of such a universe are so far removed from anything that has ever been observed or tested that the models become uncertain. But the broad picture is this: a universe of maximum entropy, in which the energy that was once concentrated in stars and black holes has been spread evenly through an enormous volume of space, in which the temperature is a fraction of a degree above absolute zero and falling, in which the density of matter is so low that the average distance between particles is measured in distances that make the current intergalactic voids look crowded. A universe in which nothing happens, not because the laws of physics have been suspended, but because there is nothing left for them to act on. No gradients, no differences, no structure, no contrast, just the cold, dark, uniform expanse of a cosmos that has reached the end of its capacity for change. This is the heat death. This is the destination toward which the universe appears to be moving. Slowly, patiently, without urgency or intention. It is not a dramatic ending. It is not a bang, or a crunch, or a rip. It is a fading, a gradual, irreversible loss of the differences that make the universe interesting, the contrasts that make events possible, the gradients that make complexity viable. It is the universe becoming, in the most complete sense, empty. Not empty of space, but empty of everything that space once contained. And here is the thing that makes this more than a scientific curiosity. Here is the thing that connects the heat death of the universe to the emptiness of the cosmic voids, and the acceleration of expansion, and the isolation of the local group, and the indifference of the cosmos to the existence of life and meaning. The heat death is not just the fate of the universe, it is the logical conclusion of everything that has been described in this journey. The emptiness of the voids, the thinning of the cosmic web, the acceleration of expansion, the shrinking of the observable universe, the cooling of the stars, the evaporation of the black holes, all of these are steps in the same process. All of these are the universe moving, in its own way and at its own pace, toward the state of maximum entropy. The heat death is not a separate event that will happen at the end of a long story. It is the end of the story that has been unfolding since the beginning. The universe began in a state of extraordinarily low entropy. The Big Bang, whatever its ultimate cause or nature, produced a cosmos of remarkable order, hot, dense, nearly uniform, with tiny fluctuations that would eventually grow into the structure we see today. That initial order was the starting point, the low entropy state from which all subsequent complexity arose. The stars, the galaxies, the planets, the living things, all of these are structures that formed as the universe moved from that initial low entropy state toward higher entropy, exploiting the gradients created by the Big Bang to build temporary islands of order in a sea of increasing disorder. Life itself is not a violation of the second law of thermodynamics. It is a consequence of it. Life is what happens when matter finds a way to increase entropy more efficiently by building complex structures that process energy and release it as heat. Every living thing is, in a thermodynamic sense, an entropy-generating machine, a temporary structure that exists by accelerating the flow of energy from high concentration to low concentration states. And when the gradients are gone, when the energy has been spread evenly and the temperature has equilibrated and the last star has gone dark and the last black hole has evaporated, the conditions that made life possible will no longer exist, not because life has been destroyed, but because the universe will no longer contain the kind of order, the kind of difference, the kind of available energy that life requires. The universe will have moved past the point where complexity is possible. It will have moved into a state where the laws of physics still apply but have nothing interesting to do. A state of perfect, permanent, irreversible sameness. There is a particular kind of silence that comes with this realization. Not the silence of a room where the noise has stopped, where you know the noise could start again. The the silence of a place where the conditions for noise no longer exist, where the air has gone, where the vibrations have ceased, where the medium through which sound travels has become so thin and so cold and so uniform that the concept of sound has lost its meaning. That is the silence toward which the universe is moving. Not the silence between sounds, but the silence after the last sound has been made, and the last echo has faded, and the last medium capable of carrying a vibration has cooled to the temperature of the void. And this silence is not coming from outside the universe. It is not being imposed by some external force or some cosmic catastrophe. It is growing from within. It is the natural, inevitable consequence of the laws that govern the universe, operating over timescales so long that they are effectively infinite by any human measure, but finite in the sense that they have a direction and a destination. The universe is not being silenced. It is silencing itself, slowly, patiently, without awareness of what it is doing or what it is losing. What is being lost is not nothing. What is being lost is everything that the universe has built over its 14 billion-year history. The stars that forged the heavy elements, the galaxies that organized those elements into systems of extraordinary complexity, the planets that provided the conditions for chemistry to become biology, the living things that developed the capacity to perceive and remember and understand, the civilizations that built instruments to measure the universe and minds to interpret those measurements. All of this, every structure, every memory, every record, every trace of everything that has ever existed, is subject to the same process. All of it will eventually be erased, not by violence but by the patient, indifferent action of entropy and expansion, and the long cooling of a universe that does not know it is losing anything. The records will go first, in a sense, not the physical records, the books and the hard drives and the stone carvings, but the cosmic records, the light from distant galaxies, which carries information about the state of the universe billions of years ago, will redshift beyond detection as those galaxies recede beyond the horizon. The cosmic microwave background radiation, the oldest light in the universe, the faint afterglow of the Big Bang itself, will cool and redshift until it is indistinguishable from the thermal noise of the vacuum. The evidence of the universe's history, the record of everything that has happened since the Big Bang, will be erased not by any deliberate act, but by the simple passage of time and the relentless expansion of space. Future observers, if they exist, will not be able to reconstruct the history of the universe from the evidence available to them. They will not be able to detect the cosmic microwave background. They will not be able to see the distant galaxies that have receded beyond the horizon. They will not be able to measure the expansion of the universe, because the only galaxies visible to them will be the gravitationally bound members of their own local group, which are not receding and therefore provide no evidence of expansion. They will look out at a universe that appears static, isolated, and eternal, with no evidence of a beginning, no evidence of a larger structure, no evidence of the billions of years of cosmic history that preceded their existence. The universe will have hidden its own past, not deliberately, not maliciously, but completely. This is one of the most unsettling implications of the accelerating expansion. We exist at a moment in cosmic history when the universe is still legible, when its past is still written in the light that surrounds us, when the evidence of the Big Bang and the cosmic web and the large-scale structure of the universe is still accessible to anyone with the right instruments and the patience to look. But this legibility is a temporary condition. It is a window that is slowly closing, and when it closes, it will close permanently. The information will not be lost in the sense of being destroyed. It will be lost in the sense of being inaccessible, carried beyond the horizon by the expansion of space, redshifted into invisibility by the stretching of the universe, diluted into the thermal noise of a cosmos that has moved on. We are, in a very real sense, living in the golden age of cosmic observation. The universe is currently at a stage where its structure is visible, its history is recoverable, and its future can be inferred from the evidence available. This will not always be the case. The window is open now. It will not always be open. And the fact that we exist at this particular moment, when the universe is still telling its own story in a language that can be read, is either a remarkable coincidence or a consequence of the fact that the conditions for observers like us require a universe at a particular stage of its development. Either way, the window is temporary, and the story it tells, when read carefully and honestly, is not a story of abundance and permanence. It is a story of emptiness and impermanence, of structures that form and dissolve, of light that travels and fades, of complexity that arises and is erased. Come back now to the beginning. Come back to that moment before full darkness, when the sky opens, and the stars appear and the universe seems full and generous and arranged for the pleasure of whoever is watching. That feeling is real. The beauty is real. The stars are real. But the feeling is also, in a precise and measurable way, a misreading of the situation. The universe is not full. It is not generous. It is not arranged for anyone. It is a vast, mostly empty, expanding, cooling structure of matter and energy, moving toward a state of maximum entropy, indifferent to the existence of the observers who have briefly arisen within it, and are now, for the first time in the history of the cosmos, capable of understanding what it is. And what it is at its core is this: a place where almost nothing exists, where the nothing is growing, and where the something that does exist is temporary. The stars are temporary. The galaxies are temporary. The planets are temporary. The living things are temporary. The civilizations are temporary. The memories are temporary. The records are temporary. The light is temporary. Everything that has ever been called real, everything that has ever been observed or measured or named or loved, is a temporary arrangement of matter in a universe that was empty before it arrived, and will be empty long after it is gone. This is not a comfortable thought. It is not meant to be. The universe does not offer comfort. It offers scale and silence and the cold precision of physical law, and the occasional improbable temporary miracle of complexity arising in the spaces between the emptiness. Those miracles are real. They are extraordinary. The fact that matter can organize itself into structures capable of asking questions about the universe is, by any measure, one of the most remarkable things that has ever happened in the 14-billion-year history of the cosmos. But remarkable does not mean permanent. Extraordinary does not mean eternal. And the universe, for all its capacity to produce wonders, is not in the business of preserving them. But the stars are not simply burning. They are burning through something finite. They are consuming a supply of hydrogen that was fixed at the moment of the Big Bang, a supply that has been decreasing ever since, converted by nuclear fusion into helium and then into heavier elements, locked away in stellar remnants, scattered through the interstellar medium, gradually becoming unavailable for the formation of new stars. The universe is not just aging, it is spending. It is drawing down a reserve of ordered energy that cannot be replenished, converting it into heat and light and the slow accumulation of entropy, and the rate at which it is spending that reserve tells a story about where it is in its own history, and how much further it has to go. Consider the stellar population of the universe over time. In the early universe, roughly 2 to 3 billion years after the Big Bang, the rate of star formation was at its peak. Galaxies were forming rapidly, gas was abundant, and the conditions for the birth of new stars were widespread and favorable. The universe was, in a sense, at its most productive during this period, generating new stars at a rate that has never been matched since. But that peak has passed. The rate of star formation in the universe has been declining for roughly 10 billion years, falling as the available gas is consumed and the conditions for star formation become less common. The universe is not at its peak. It is past its peak. It is in a long, slow decline, still producing stars, still generating light, but doing so at a fraction of the rate it once did, and that fraction is itself declining. This decline is not a crisis. It is not a sudden change. It is a gradual, almost imperceptible shift in the balance between the processes that create structure and the processes that dissolve it. But it is real, and it is measurable, and it points in the same direction as everything else that has been described, toward a universe that is slowly, steadily, irreversibly losing its capacity to do the things that make it interesting. The universe is not dying in any dramatic sense. It is aging. It is moving through a long sequence of stages, each one slightly dimmer and slightly quieter than the last, each one a step further from the bright, productive, energetic state it occupied in its youth. And the aging of the universe is not uniform. Different structures age at different rates, and the sequence in which they fade tells its own story about the hierarchy of cosmic time. The most massive stars, the giants that burn hundreds of times brighter than the sun, exhaust their fuel in millions of years and die in spectacular supernova explosions, seeding the interstellar medium with the heavy elements forged in their cores. These stars are the universe's most extravagant spenders, burning through their reserves at a furious rate and leaving behind neutron stars or black holes as their final testament. They are brilliant and brief, the mayflies of the stellar world, and their deaths are among the most energetic events in the universe. But they are already rare, and they are becoming rarer, as the gas that feeds their formation is consumed, and the conditions that favor their birth become less common. The Sun-like stars, the middleweight members of the stellar population, burn more slowly and more steadily. The Sun has been burning for approximately 4.6 billion years and has roughly another 5 billion years of hydrogen fuel remaining. When that fuel is exhausted, the Sun will expand into a red giant, swelling to a size that will engulf the inner planets, and then shed its outer layers in a slow, beautiful exhalation of gas and dust that will form a planetary nebula, a glowing shell of ionized material surrounding the dense, hot core that remains. That core, a white dwarf roughly the size of Earth but containing most of the Sun's original mass, will cool slowly over billions of years, fading from white to yellow to orange to red to the invisible infrared, and eventually to a cold, dark sphere indistinguishable from the surrounding space. This is the fate of the Sun. This is the fate of most of the stars currently burning in the Milky Way and in every other galaxy in the observable universe. Not explosion, not collapse into a black hole, just a slow, quiet fading, a gradual loss of the temperature gradient that makes the star a star, until the gradient is gone, and the star is gone, and what remains is a cold remnant that carries no memory of the fire it once was. The white dwarf does not know it was a star. It does not mourn the loss of its fusion reactions. It simply cools, following the laws of thermodynamics with perfect, indifferent compliance, moving toward equilibrium with the surrounding space at a rate determined by its mass and its surface area and the temperature of the universe around it. The red dwarf stars will outlast all of them. These small, dim, cool stars, which make up the majority of the stellar population by number, burn their hydrogen so slowly and so efficiently that they can persist for trillions of years. A red dwarf with a mass of about 10% of the Sun's mass may burn for 10 trillion years or more, a timescale so long that it makes the current age of the universe seem like a brief prologue. During the long era of the red dwarfs, the universe will be a dim, quiet place. The brilliant blue and white stars will be long gone. The Sun-like stars will have faded to white dwarfs. The galaxies will be populated primarily by the faint red glow of these small, patient stars, burning slowly in the dark, and by the cold remnants of everything that came before them. But even the red dwarfs will end. Even the most patient stars will exhaust their fuel, and when they do, the era of stars will be over. Not the era of stellar remnants, which will persist for far longer, but the era of nuclear fusion, the era in which the universe contains objects that generate energy by fusing lighter elements into heavier ones, the era in which the universe is lit by the fire of ongoing nuclear reactions. That era will end. And when it ends, the universe will enter a new phase, a phase that has no name in human experience because nothing in human experience resembles it. A phase in which the universe is populated by cold, dark objects drifting through an expanding space, interacting occasionally through gravity, slowly losing energy to the surrounding void, moving toward a state of complete and permanent equilibrium. In this phase, the dominant objects will be white dwarfs, neutron stars, and black holes. The white dwarfs will cool toward the temperature of the surrounding space, becoming black dwarfs over timescales of quadrillions of years. The neutron stars will spin down, losing their rotational energy to the surrounding space through the emission of gravitational waves and electromagnetic radiation, becoming cold, dark spheres of neutron-degenerate matter. The black holes will persist the longest. Their mass is so enormous that the Hawking radiation they emit is negligible on any timescale, shorter than the age of the universe, raised to enormous powers. But they too will evaporate, slowly, over timescales that make the era of the red dwarfs look instantaneous. And during all of this, the universe will continue to expand. The space between the remnants will continue to grow. The distances between the cold, dark objects drifting through the post-stellar universe will increase slowly at first, then faster, as dark energy continues to accelerate the expansion. The remnants will not be destroyed by the expansion. They will simply be moved further apart, isolated from each other by distances that grow without limit, until the probability of any two remnants ever interacting again approaches zero. The universe will become a collection of isolated objects, each one alone in an expanding space, each one cooling toward the temperature of the void, each one moving toward the final equilibrium that the second law of thermodynamics has been pointing toward since the beginning. There is a concept in physics called the Poincare recurrence time, a theoretical timescale after which a closed system will, by pure statistical chance, return to a state arbitrarily close to its initial state. For a system as large and as complex as the universe, this timescale is so enormous that it is effectively meaningless, a number so large that it cannot be written out in full, even if every particle in the observable universe were used as a digit. but the concept is worth mentioning because it illustrates something important about the nature of time and entropy. Even in a universe of maximum entropy, even in the heat death, the laws of physics do not stop. Quantum fluctuations continue. Virtual particles continue to appear and disappear. The vacuum is not truly empty in the quantum mechanical sense, but seething with activity at scales so small and so brief that they have no macroscopic consequences. The universe does not stop. It simply stops doing anything that matters, by any definition of mattering that requires structure or complexity, or the flow of energy from one place to another. This is the final silence. Not the silence of a universe that has been destroyed, but the silence of a universe that has been completed. A universe that has run through its entire repertoire of possible events, exhausted every gradient, dissolved every structure, and arrived at the state toward which it was always moving. A universe that is, in the most complete sense, done, not ended, not destroyed, just finished, just arrived at the destination that the second law of thermodynamics set for it at the moment of its birth. And here is the thought that is most difficult to hold. Here is the thought that sits at the center of everything that has been described. The thought that connects the emptiness of the voids to the fate of the stars, to the heat death of the universe, to the question of what it means to exist inside all of this. The universe does not know that it is losing anything. It does not experience the fading of the stars as a loss. It does not register the cooling of the galaxies as a tragedy. It does not notice the evaporation of the last black hole, or the dissolution of the last structure, or the arrival of the final equilibrium. The universe is not a subject. It is not an observer. It is a physical system, governed by laws that operate without awareness or intention, moving through a sequence of states that have no meaning to the system itself. The meaning, if there is any, exists only in the minds of the observers who have briefly arisen within it, and are now, for the first time, capable of understanding what is happening, and those observers are temporary. The conditions that make observers possible, the availability of energy, the existence of chemical gradients, the presence of liquid water and organic molecules, and the complex chemistry of life, are not permanent features of the universe. They are features of this particular epoch, this brief window in cosmic history when the universe is neither too hot nor too cold, neither too young nor too old, when the stars are still burning, and the galaxies are still forming, and the conditions for complexity are still present. That window will close. It is already closing slowly, at the pace of cosmic time, and when it closes, the observers will be gone, and with them the only things in the universe that were capable of noticing what was being lost. This is the existential consequence that the emptiness of the universe points toward. Not just that the universe is large and we are small, not just that the universe is old and we are brief, but that the universe is structured in a way that makes observers possible only temporarily, only in a narrow window of cosmic time, only under conditions that are themselves the product of a process that is moving inexorably toward a state in which those conditions no longer exist. We are not just small and brief. We are contingent. We are the product of a set of circumstances that arose by the operation of physical laws and will be dissolved by the same laws, on a time scale that is long by human standards, but finite by cosmic ones. The night sky, seen from this perspective, is not a window into abundance. It is a window into a moment, a specific, unrepeatable moment in the history of a universe that was different before this moment and will be different after it. The stars you see are not permanent fixtures. They are events. They are processes. They are the temporary conversion of hydrogen into helium and heat and light, happening right now, in this epoch, under conditions that will not persist. The light reaching your eyes left those stars years or decades or centuries ago, and in the time since it left, those stars have aged. Some of them have died, and the universe has moved a little further along the path toward the silence that waits at the end of its history. You are watching the universe in the act of spending itself. You are watching the conversion of order into disorder, of structure into uniformity, of the particular into the general. You are watching entropy increase, not as an abstract thermodynamic process, but as the actual physical ongoing transformation of the cosmos from a state of remarkable order into a state of featureless equilibrium. And you are watching it from inside, as a product of that process, as a temporary structure of matter that has achieved the improbable capacity to observe and understand the process that produced it, and will eventually dissolve it. There is something in this that is not simply disturbing. There is something in it that is, in a strange and difficult way, remarkable. The universe did not have to produce observers. The laws of physics did not require the existence of creatures capable of asking questions about the nature of the cosmos. the second law of thermodynamics, does not care whether anyone is watching the entropy increase. And yet, here, in this particular corner of this particular galaxy, in this particular epoch of cosmic history, matter has organized itself into a form that can look up at the night sky and ask what it is looking at. That is not nothing. That is, by any measure, an extraordinary thing to have happened. But extraordinary does not mean significant in the cosmic sense. The universe does not assign significance. It does not rank events by their importance or their complexity or their capacity to generate meaning. A supernova and a thought are both physical processes, both governed by the same laws, both moving in the same direction toward higher entropy. The thought is more complex. The thought is more interesting, at least to the thinker. But the universe does not share the thinker's assessment. The universe processes both events with equal indifference, moving forward in time, increasing in entropy, expanding in space, cooling toward the equilibrium that waits at the end of everything. And this indifference is not a flaw in the universe. It is not a deficiency or a failure. It is simply what the universe is, a physical system, not a moral one. A structure governed by laws, not by values. A place where things happen according to the rules of physics, not according to the preferences of the things that happen to exist within it. The universe is not cruel. It is not kind. It is not indifferent in the way a person is indifferent, with the implication that it could choose to care but has decided not to. It is indifferent in the way that a mathematical equation is indifferent, completely, structurally, by definition. This is the hardest thing to accept about the universe. Not its size, which is merely incomprehensible. Not its age, which is merely unimaginable. Not its emptiness, which is merely disturbing. But its indifference, which is something else entirely. Because the size and the age and the emptiness are properties of the universe that can be measured and described and, in some sense, accommodated. They are facts about the universe that can be held at a distance, examined, understood. But the indifference is not a property that can be held at a distance. It is a property that reaches into the question of meaning itself, into the question of whether the existence of observers and the questions they ask and the answers they find have any significance beyond the local, temporary, contingent significance they assign to themselves. The universe does not answer this question. It cannot. It is not the kind of thing that answers questions. It is the kind of thing that questions are asked about by the temporary structures of matter that have briefly achieved the capacity to ask them, and the answers those structures find, when they look carefully and honestly at the universe they inhabit, are not comforting. They are precise. They are measurable. They are, in their own way, beautiful, but they are not comforting. The universe is mostly empty. The matter that exists is arranged in thin filaments around enormous voids. The visible matter is a minority of the total mass energy content. The invisible components, dark matter and dark energy, dominate the universe's structure and dynamics. The expansion of the universe is accelerating, driven by a force or property of space that is not yet understood. The observable universe is shrinking as galaxies recede beyond the cosmic horizon. The stars are burning through a finite supply of fuel. The rate of star formation is declining. The universe is aging, cooling, thinning, moving toward a state of maximum entropy in which no structure, no complexity, no observer, and no memory of any of these things will be possible. These are the facts. Not all of them, not the complete picture, not the final word on a universe that still contains enormous mysteries and unanswered questions, but the broad outline, the direction, the trajectory. The universe is moving away from complexity and toward simplicity, away from structure and toward uniformity, away from the conditions that make observers possible and toward the conditions that make observers impossible. And it is doing so, not because of any external force or any cosmic catastrophe, but because of the laws that govern it, operating exactly as they always have, producing exactly the outcomes they always produce. Step back one more time. Step back to the largest scale, to the view from which the cosmic web is visible as a pattern of filaments and voids, to the perspective from which individual galaxies are invisible, and the structure of the universe itself is the object of attention. From this perspective, the universe looks like what it is: a vast, mostly empty structure, organized around absence, populated by rare concentrations of matter that are themselves mostly empty, embedded in a space that is expanding and cooling and moving toward equilibrium. It looks like a place that is, in its totality, defined by what it lacks rather than by what it contains, defined by the voids rather than the filaments, defined by the darkness rather than the light, defined by the silence rather than the sound, and the light, when you look at it from this perspective, is not the dominant feature. It is the exception. It is the rare, temporary, improbable consequence of matter finding itself in conditions where nuclear fusion is possible, where gravity has compressed gas to the point where hydrogen nuclei can overcome their mutual repulsion and merge, releasing the energy that makes a star a star. That process is happening right now, in billions of stars across the observable universe, but it is happening in a tiny fraction of the total volume of the cosmos, in the thin filaments of the cosmic web, in the dense cores of galaxies, in the rare and isolated concentrations of matter that represent the universe's brief experiment with structure. The rest of the universe, the vast majority of its volume, is dark, is cold, is empty, is silent. The light is the exception. The darkness is the rule, and the darkness is not waiting for the light to fill it. It is not a temporary condition that will eventually be resolved by the spread of stars and galaxies into the empty regions. The empty regions are not empty because the matter has not arrived yet. They are empty because the matter has left, drawn away by gravity into the surrounding filaments, or because the matter was never there in sufficient quantity to form structures. The voids are not the future of the filaments. They are the present of the universe, the dominant feature of the cosmos as it actually exists. Right now, in this moment, as you are reading these words and the light from distant galaxies is traveling through the emptiness toward instruments that may or may not be pointed in the right direction to receive it. The light is traveling. It has always been traveling. Every photon emitted by every star in every galaxy is moving outward through the universe at the maximum speed the laws of physics permit, carrying information about the state of the star that emitted it, about the temperature and composition and motion of the matter it passed through on its way to wherever it is going. Most of that light will never reach anything. Most of it will travel through the emptiness of intergalactic space for billions of years, growing fainter with distance, redshifting toward longer and longer wavelengths as the expansion of the universe stretches the space it is traveling through, until it is so faint and so redshifted that no instrument could detect it, and it becomes, for all practical purposes, as if it never existed. The universe is full of light that will never be seen, full of signals that will never be received, full of information that will never be read. The photons emitted by stars in the deep voids, the rare rogue stars burning in the emptiness between galaxy clusters, are traveling through a space so empty that the probability of any of their photons ever encountering another atom is vanishingly small. They will travel forever, or until the expansion of the universe has redshifted them into the microwave background, carrying their information about a star that burned alone in the dark, witnessed by nothing, remembered by nothing, as if it had never existed at all. And this is the final image, not the night sky with its apparent abundance of stars, not the cosmic web with its intricate architecture of filaments and voids, not the accelerating expansion or the shrinking horizon or the cooling remnants of the post-stellar universe. The final image is simpler than any of these. It is a photon, traveling through the dark, emitted by a star that has since gone cold, carrying information about a moment that no longer exists, moving through a space that is expanding around it, stretching its wavelength, diluting its energy, carrying it further and further from anything that could receive it, moving through the emptiness that is the universe's dominant feature, its most fundamental truth, its most honest self-description. That photon will not arrive anywhere. It will not be absorbed. It will not be detected. It will not be interpreted. It will simply travel, growing fainter, growing redder, growing more and more indistinguishable from the background noise of a universe that has moved on. And eventually, in a time so distant that the word eventually loses its meaning, it will be so redshifted and so diluted that it is effectively gone, absorbed into the thermal noise of a universe approaching equilibrium, its information lost, its journey complete, its existence as unremarked upon by the universe as the existence of the star that emitted it. This is what the universe is. This is what the emptiness means. Not just that there is a lot of space between things, but that the space is growing, and the things are temporary, and the light that connects them is finite, and the time in which any of this can be known is limited. The universe is not a place that was built for observers. It is a place where observers have briefly, improbably, remarkably arisen, and where the conditions that made their existence possible are themselves temporary features of a cosmos that was empty before they arrived and will be empty long after they are gone. The night sky is beautiful. The stars are real. The light is real. The wonder is real. But the wonder is a local phenomenon, a product of the particular position and the particular moment and the particular arrangement of matter that makes it possible to look up and feel something. The universe taken as a whole does not share the wonder. It does not feel the beauty of its own stars. It does not notice the improbability of the observers who have arisen within it. It simply expands. It simply cools. It simply moves without awareness or intention toward the silence that has always been its destination. And the silence is patient. It has been waiting since before the first star was born. It waited through the formation of the first galaxies, through the peak of star formation, through the long decline of the stellar era, through the cooling of the white dwarfs, and the evaporation of the black holes. It is waiting now, in the voids between the filaments, in the spaces between the stars, in the emptiness that makes up the overwhelming majority of the universe's volume. It is not threatening. It is not malevolent. It is simply there, as it has always been there, as it will always be there. The dominant feature of a universe that is, at its core, defined by absence. And yet the interruption persists. For now, in this moment, in this epoch, in this narrow window of cosmic time, the interruption is real and present and extraordinary. The stars are burning, the galaxies are turning, the light is traveling, the observers are watching, and the watching matters, not because the universe assigns it significance, but because the watchers do. Because the capacity to assign significance is itself one of the most improbable things that has ever emerged from the operation of physical law, and the fact that it exists at all, even temporarily, even contingently, even in a universe that will eventually erase every trace of it, is something that deserves to be held with full awareness of what it is. But holding it with full awareness means holding it without illusion. It means looking at the universe as it actually is, not as the night sky suggests it is, not as human intuition would prefer it to be, but as the instruments and the mathematics and the careful, patient work of generations of scientists have revealed it to be. And what they have revealed is a universe that is, in its totality, something quite different from the inhabited, purposeful, observer-friendly cosmos that the view from Earth might suggest. It is a universe of overwhelming emptiness, of accelerating separation, of cooling and fading and the slow dissolution of every structure that complexity has managed to build. The dissolution is not happening quickly. On human timescales, on the timescale of a civilization or a species or even a geological epoch, the universe appears stable. The stars appear permanent. The galaxies appear fixed. The night sky appears unchanging. But the appearance of permanence is a consequence of the mismatch between human timescales and cosmic ones, not a property of the universe itself. The universe is changing. It has always been changing, and the direction of that change, followed to its conclusion, leads not to a richer, more complex, more inhabited cosmos, but to a simpler, emptier, colder, darker one. This is the direction. This is the arrow. Not the arrow of time in the abstract, not the philosophical concept of temporal direction, but the physical, measurable, observable direction in which the universe is actually moving. Away from the Big Bang and toward the heat death, away from the initial low entropy state and toward the final high entropy equilibrium, away from the conditions that make complexity possible and toward the conditions that make it impossible. The universe has a direction, and that direction is not toward us. It is not toward life or consciousness or meaning. It is toward the silence that has always been waiting at the end of the story. Consider what this means for the question of cosmic significance, the question of whether the universe has a purpose. Whether it was designed or intended or arranged with any particular outcome in mind is a question that science cannot answer directly. But science can describe the universe's behavior, and the behavior it describes does not suggest a cosmos oriented toward the production or preservation of complexity. The universe produces complexity as a side effect of entropy increase, as a temporary consequence of the flow of energy from high concentration to low concentration states. Life, consciousness, civilization, these are not the goals of the universe. They are the foam on the surface of a thermodynamic process, beautiful and intricate and real, but not the point. The point, if the universe can be said to have one, is the increase of entropy, and entropy does not require observers. It does not require complexity. It does not require anything except the operation of physical law over sufficient time. The foam will dissipate. The thermodynamic process will continue. And the universe, after the foam is gone, will be exactly what it was before the foam appeared. A physical system moving toward equilibrium, indifferent to what has been lost, unaware that anything was ever there. But something was there. Something is there, right now, in this moment. The foam is real. The complexity is real. The observers are real. And the questions they ask, the understanding they build, the meaning they construct from the raw material of physical law and cosmic history. These are real too, in the only sense that real can mean for things that exist inside a universe that does not assign reality to anything. They are real because they are happening. They are real because the matter that constitutes them is arranged in a way that makes them possible. They are real for exactly as long as the arrangement persists and not one moment longer. This is the condition of existence in this universe. Not permanence, but presence. Not eternity, but now. The universe does not offer permanence. It does not offer eternity. It does not offer the preservation of complexity or the protection of observers or the continuation of meaning beyond the physical conditions that make meaning possible. What it offers, if offer is even the right word, is the present moment, the current arrangement, the temporary configuration of matter and energy that makes this particular experience of the cosmos possible. And then it takes that back, slowly, patiently, without malice. As the entropy increases and the gradients flatten and the conditions change, there is a particular kind of vertigo that comes from understanding this fully. Not the vertigo of height, where the danger is physical and the ground is visible below. The vertigo of scale, where the danger is conceptual and the ground is the assumption that the universe is, in some fundamental way, on your side. That assumption is not supported by the evidence. The universe is not on anyone's side. It is not against anyone either. It is simply operating, following its laws, moving in its direction, producing its outcomes without reference to the preferences of the structures that temporarily exist within it. And the structures that temporarily exist within it include everything. Every star, every galaxy, every planet, every living thing, every civilization, every thought, every memory, every record of every event that has ever occurred in the 14 billion-year history of the cosmos. All of it is temporary. All of it is subject to the same laws, moving in the same direction, heading toward the same destination. The destination is not destruction, it is dissolution. It is the gradual, irreversible loss of the differences that make things things, the contrasts that make events events, the gradients that make processes processes. It is the universe becoming, in the most complete and final sense, undifferentiated, uniform, finished. And when it is finished, there will be no one to notice. There will be no observer to register the completion of the process, no consciousness to experience the final equilibrium, no memory to hold the record of everything that came before. The universe will have erased not just its structures, but its witnesses, not just its complexity, but its capacity for complexity, not just its observers, but the conditions that made observation possible. The silence will be complete, not because it has silenced something, but because there is nothing left to make a sound. This is the ending that the physics points toward, not the ending of a story, with its implication of narrative and meaning and the satisfaction of resolution, the ending of a process, the completion of a thermodynamic trajectory that began at the Big Bang and ends at the heat death, passing through 14 billion years of structure and complexity and light and life, on its way to the final equilibrium. The story is not the point. The story is what happened along the way, in the space between the beginning and the end, in the brief and improbable interval when the universe was neither too hot nor too cold, neither too young nor too old, when the conditions for complexity were present and the matter took advantage of them. That interval is now. We are inside it. We are the advantage that matter took of the conditions. We are the complexity that arose in the space between the Big Bang and the heat death, in the window when the universe was capable of producing observers, and the observers were capable of understanding what they were observing. And what they are observing, when they look carefully and honestly, is a universe that is beautiful and vast and extraordinary and temporary, a universe that is, in its totality, moving away from them, moving away from complexity, away from structure, away from the conditions that make their existence possible, toward the silence and the dark and the cold that have always been the universe's dominant features and will eventually be its only features. The expansion continues. Right now, as these words are spoken, the universe is expanding. The galaxies beyond the local group are receding. The space between them and us is growing. The light they are emitting right now, the light that is leaving their stars at this moment, is beginning a journey that will take billions of years. And at the end of that journey, if the expansion continues to accelerate, that light may never arrive. It may be carried away by the expansion faster than it can travel, redshifted into invisibility before it can reach any observer, lost in the growing darkness between the receding galaxies and the shrinking horizon of the observable universe. The universe is not waiting for us to finish understanding it before it moves on. It is not pausing while we build our instruments, and refine our models and extend our observations. It is expanding at the same rate it has always expanded, accelerating at the same rate it has always accelerated, cooling at the same rate it has always cooled. The process does not care about the observers. The process does not know about the observers. The process is simply the process, operating according to its laws, producing its outcomes, moving in its direction. And the direction, followed far enough, leads to a place where the concept of direction itself becomes meaningless. Because direction requires difference, requires a gradient, requires a distinction between here and there, between now and then, between this state and that state. In the final equilibrium, those distinctions are gone. Every point in the universe is the same as every other point. Every moment is the same as every other moment. The universe has not ended. It has simply become indistinguishable from itself at every scale, in every direction, at every time. It has become, in the most complete sense, nothing in particular. Not nothing, just nothing in particular. Just the featureless, uniform, cold, dark, infinite expanse of a cosmos that has exhausted its capacity for difference. There's a question that this raises, a question that sits at the very edge of what physics can address and what philosophy must take over. If the universe began in a state of low entropy and is moving toward a state of high entropy, if the direction of time is defined by the increase of entropy, then what was before the low entropy beginning? What produced the initial conditions of the Big Bang, the remarkable order that made all subsequent structure possible? This is a question that current cosmology cannot fully answer. The Big Bang is the boundary of our current models, the point beyond which the physics breaks down and the questions become unanswerable with the tools currently available. But the question itself is important because it points to something that the story of the universe's fate tends to obscure. The beginning was as remarkable as the ending is inevitable. The universe began in a state of extraordinary order. Not perfect order, but order so much greater than the current state of the universe that the difference is almost incomprehensible. The initial conditions of the Big Bang were, by any measure, improbable. Not impossible, not miraculous in any supernatural sense, but improbable in the precise technical sense that the number of possible initial conditions that would have led to a universe like ours is a tiny fraction of the total number of possible initial conditions. The universe we inhabit, with its stars and galaxies and planets and life, is not the most likely outcome of a random set of initial conditions. It is a specific outcome, produced by a specific set of initial conditions, and the question of why those conditions were what they were is one that physics has not yet answered. This uncertainty is important. It is a reminder that the story of the universe, for all its apparent inevitability when told from the present looking forward, is not fully understood when told from the beginning looking forward. The heat death may be the destination, but the origin is still mysterious. The laws of physics may be clear, but the reason those laws are what they are, the reason the initial conditions were what they were, the reason the universe exists at all rather than not existing, these are questions that remain open. And they are questions that the universe itself cannot answer, because the universe is the thing the questions are about, not the thing that answers them. But the mystery of the origin does not change the direction of the trajectory. Whatever produced the initial conditions of the Big Bang, whatever set the universe in motion with the particular properties it has, the result is a cosmos that is moving in a specific direction, governed by specific laws, heading toward a specific destination. The mystery of the beginning does not make the ending less certain. It simply makes the whole story more strange, more improbable, more difficult to hold in the mind as a coherent whole. A universe that began in remarkable order, produced extraordinary complexity in the interval between its birth and its death, and will end in perfect, featureless equilibrium. A universe that was, briefly, something, and will be, eventually, nothing in particular. Return one final time to the night sky. Return to that moment before full darkness, when the first stars appear and the universe seems to open and the feeling of abundance and wonder arises naturally, without effort, without instruction. That feeling is not wrong. It is not a mistake. It is a genuine response to a genuine phenomenon. The light of distant stars traveling through the emptiness of space, arriving at the surface of a planet where matter has organized itself into a form capable of receiving it and responding to it with something that functions like awe. That is real. That is happening. That is one of the most extraordinary things in the known universe. But the feeling is incomplete. It is the feeling of someone who has seen the highlights and not yet read the full account. It is the feeling of someone standing at the edge of a vast territory, seeing only the near edge, the part that is lit and close and comprehensible, and not yet aware of how far the territory extends, how dark it becomes, how empty it is at its center, how cold it is at its edges, how certain it is that the light at the near edge is temporary, and the darkness at the far edge is permanent. The full account is harder to hold. It requires sitting with the knowledge that the universe is mostly empty, that the emptiness is growing, that the structures that interrupt the emptiness are temporary, that the observers who notice the structures are more temporary still, and that the universe will continue long after the last observer has gone, expanding and cooling and moving toward equilibrium, indifferent to the absence of anyone to witness it. It requires holding all of that without flinching, without retreating into the comfortable illusion of the night sky, without pretending that the wonder of the near edge is the whole story. The whole story is this: the universe is a physical system of extraordinary scale and complexity, governed by laws that produce structure as a temporary consequence of entropy increase, and that structure includes, for a brief interval in cosmic time, the conditions necessary for observers to exist. Those observers have used their brief existence to understand the system they are part of, and what they have understood is that the system is not built for them, is not oriented toward them, is not aware of them, and will not preserve them. The system will continue after they are gone, moving in the same direction it has always moved, following the same laws it has always followed, producing the same outcome it has always been heading toward, and the outcome is silence. Not the silence of a universe that has been emptied by some catastrophe, not the silence of a universe that has been destroyed or collapsed or torn apart, the silence of a universe that has simply finished, that has run its course, that has converted its initial order into its final disorder, its initial structure into its final uniformity, its initial complexity into its final simplicity, the silence of completion, the silence of a process that has reached its end and has nothing left to do and no one left to notice that it is done. The voids between the galaxies are already practicing this silence. They have been practicing it for billions of years, growing larger and emptier as the expansion carries matter away from their centers and into the surrounding filaments. They are the advanced scouts of the universe's future, the regions where the final state has already, in some sense, arrived. Not perfectly, not completely, not yet, but closer than anywhere else, closer to the equilibrium, closer to the silence, closer to the state that the rest of the universe is slowly, inevitably approaching, and the filaments, the clusters, the galaxies, the stars, all of these are the resistance. All of these are the temporary structures that gravity has built against the tide of entropy and expansion, the local exceptions to the universal rule of emptiness and dissolution. They are remarkable. They are beautiful. They are, in the context of a universe that is mostly nothing, almost miraculous. But they are losing, not quickly, not dramatically, but steadily, over timescales that make human history look like a single heartbeat. They are losing. The entropy is increasing. The expansion is accelerating. The stars are aging. The gradients are flattening. The resistance is weakening. It has always been weakening. From the moment the first star ignited, from the moment the first galaxy formed, from the moment the first complex molecule assembled itself in the warm chemistry of some ancient planetary surface, the process of dissolution has been underway. Every star that burns is spending the universe's reserve of ordered energy. Every supernova that scatters heavy elements through the interstellar medium is increasing the entropy of the cosmos. Every living thing that metabolizes and grows and reproduces is generating heat, increasing disorder, moving the universe a tiny, imperceptible step closer to the equilibrium that waits at the end of everything. Life is not the opposite of entropy. Life is entropy's most sophisticated instrument. This is not a reason to despair, or perhaps it is depending on what you were hoping for, but it is, at minimum, a reason to look clearly, to see the universe as it is, not as the night sky suggests it is, not as human intuition would prefer it to be, to see the emptiness as the dominant feature, the expansion as the dominant process, the entropy as the dominant direction, to see the stars and the galaxies and the living things as the exceptions, the temporary interruptions, the brief and improbable configurations of matter that have arisen in the space between the beginning and the end, and have, for a moment, been capable of understanding their own situation. Understanding your own situation is not the same as being comfortable with it. The universe does not offer comfort. It offers clarity, if you are willing to look. And the clarity it offers is this: you are here now in a universe that is mostly empty and becoming more so, that is cooling and expanding and moving toward a silence that will be complete and permanent. You are a temporary arrangement of matter that has achieved the improbable capacity to know this, and the knowing changes nothing about the trajectory of the universe. The universe will continue in the same direction, regardless of whether anyone understands it. The entropy will increase. The expansion will accelerate. The stars will fade. The silence will deepen. But the knowing is not nothing. The knowing is, in fact, the most extraordinary thing that the universe has produced in its 14 billion-year history. Not the stars, which are simply nuclear furnaces. Not the galaxies, which are simply gravitational structures. Not even life, which is simply chemistry. But the capacity to look at the universe and understand it, to trace the arc of its history, from the Big Bang to the heat death, to measure the emptiness of the voids and the acceleration of the expansion and the direction of the entropy, to hold all of that in a mind made of atoms forged in stellar cores and ask what it means. That is something that the universe has never done before, as far as we know. That is something that may be unique to this moment, this epoch, this narrow window of cosmic time, and the window is closing. Not today, not in any human lifetime, or any number of human lifetimes, but on the timescale of the cosmos, the window is closing. The conditions that make observers possible are temporary. The stars that power the chemistry of life are aging. The galaxies that provide the environments for planetary systems are slowly exhausting their gas. The universe is moving, step by step, away from the conditions that made this moment possible, toward the conditions that will make moments like this impossible. The window will close, the knowing will end, and the universe will continue, unknowing, in the dark. There is a particular quality to this realization that is different from ordinary fear or ordinary sadness. It is not the fear of death, which is personal and immediate and bounded by a human lifetime. It is something larger and quieter and more final. It is the recognition that the universe itself is mortal, in the sense that the universe as a place where things happen, where complexity exists, where observers are possible, is a temporary condition. The universe will outlast everything inside it, but the universe as a meaningful place, as a place where meaning is even possible, will not outlast the conditions that make meaning possible, and those conditions are already in decline. The cosmic microwave background radiation, the oldest light in the universe, is currently at a temperature of approximately 2.7 degrees above absolute zero. It is cooling. As the universe expands, the wavelengths of this radiation are stretched, and its temperature falls. In the far future, it will cool to a fraction of a degree above absolute zero, then to a fraction of a fraction, approaching but never quite reaching the absolute zero that represents the complete absence of thermal energy. The universe is cooling toward a temperature that it will approach asymptotically, getting closer and closer to absolute zero without ever quite arriving, in the same way that the entropy approaches its maximum without ever quite reaching it in finite time. This cooling is not dramatic, it is not perceptible on any human timescale, but it is real, and it is ongoing, and it is the physical expression of the universe's direction. The universe is getting colder. It has been getting colder since the Big Bang, when it was hot enough to prevent the formation of atoms, hot enough to prevent the formation of nuclei, hot enough to be a uniform plasma of fundamental particles. It has cooled from that initial state, through the formation of atoms, through the formation of stars, through the formation of galaxies, through the formation of planets and life and civilizations, and the instruments that measure its temperature. And it will continue to cool, through the death of the stars and the evaporation of the black holes and the dissolution of the last structures, toward the final temperature that represents the completion of the process. Cold is the universe's natural state. Warmth is the exception. The warmth of a star, the warmth of a planet's surface, the warmth of a living body. These are all local, temporary departures from the cold that surrounds them, maintained by the flow of energy from high concentration sources that are themselves temporary. The sun is warm because it is fusing hydrogen, and it will fuse hydrogen for another 5 billion years, and then it will stop, and the warmth it provided will be gone, and the cold that was always surrounding it will close in. The universe does not generate warmth, it dissipates it. It takes the warmth that was concentrated in the initial conditions of the Big Bang and spreads it evenly, irreversibly, across an ever larger volume of space, until the warmth is so diluted that it is indistinguishable from the cold. You are warm. Right now, in this moment, the matter that constitutes you is maintaining a temperature far above the cosmic average, sustained by the chemical reactions of your metabolism, powered ultimately by the light of a star that is itself powered by the nuclear reactions of its core. You are a local, temporary exception to the cold. You are a small, brief, improbable concentration of warmth in a universe that is overwhelmingly cold and getting colder. And the warmth you represent, the complexity you embody, the awareness you possess, all of it is borrowed from the ordered energy of the Big Bang, spent a little at a time by every process that has occurred since then, and will eventually be returned to the universe as heat, as entropy, as the featureless warmth of a cosmos approaching equilibrium. This is not a metaphor. This is thermodynamics. This is the physical description of what you are and where you came from and where you are going, not as an individual but as a structure of matter in a universe governed by the second law. You are a temporary configuration of low entropy matter in a universe that is moving toward high entropy. You are the universe's way of being complex for a while, before the complexity dissolves and the matter returns to the simpler arrangements that the laws of physics favor in the long run. And the long run is very long. Long enough that the complexity has time to become extraordinary before it dissolves. Long enough for stars to form and burn and die and scatter their elements. Long enough for planets to form and cool and develop chemistry. Long enough for chemistry to become biology, and biology to become consciousness, and consciousness to become the capacity to look up at the night sky and ask what it is. Long enough for all of that to happen, and for the asking to produce answers, and for the answers to reveal a universe that is, in its totality, moving away from the conditions that made the asking possible. The asking will end, not today, not soon, by any human measure, but the asking will end, because the conditions that make asking possible will end, because the universe is moving in a direction that does not preserve those conditions, because the entropy is increasing, and the expansion is accelerating, and the stars are aging, and the gradients are flattening, and the silence is deepening. The asking will end, and the universe will continue, and the silence will be complete. And in that silence, there will be no memory of the asking, no record of the questions, no trace of the answers, no evidence that the universe was ever anything other than what it will be at the end: cold, dark, uniform, empty of difference, empty of structure, empty of the complexity that briefly interrupted its long drift toward equilibrium. The universe will not remember the stars. It will not remember the galaxies. It will not remember the living things, or the civilizations, or the questions, or the understanding. It will not remember anything because memory requires structure, and structure requires gradients, and gradients require the kind of ordered energy that the universe is spending and will eventually exhaust. The universe will forget everything, not because it chose to forget, not because the memories were destroyed, but because the physical conditions that make memory possible will no longer exist. Memory is a physical process. It requires matter arranged in specific configurations, maintained by the flow of energy, sustained against the tendency of entropy to dissolve those configurations into simpler, more probable arrangements. When the energy is gone, the configurations dissolve. When the configurations dissolve, the memory is gone. Not stored somewhere else, not transferred to another medium, gone, in the only sense that matters, inaccessible, irretrievable, as if it never existed. This is the final consequence of the emptiness. Not just that the universe is mostly empty now, not just that the emptiness is growing, not just that the structures that interrupt the emptiness are temporary, but that the memory of those structures is also temporary. That the record of everything that has ever happened in the universe is itself subject to the same laws that govern everything else, moving in the same direction, heading toward the same destination. The universe is not just losing its complexity, it is losing its history. It is moving toward a state in which its own past is inaccessible, in which the evidence of everything that came before has been erased by the very processes that produced it. We are the universe's memory for now. We are the structures that hold the record of cosmic history, that have built the instruments to read the light of distant galaxies, and the cosmic microwave background, and the large-scale structure of the universe, that have assembled the story of the cosmos from the evidence available in this particular moment of cosmic time. We are temporary archivists of a universe that will eventually have no archive. And the archive we are building, the understanding we are accumulating, the story we are telling about the universe and its history and its fate, all of it will end when we end, and the universe will continue without it. Unknowing, in the dark, unless the capacity for knowing is more durable than the current conditions suggest, unless the complexity that has arisen in this window of cosmic time finds ways to persist beyond the conditions that produced it, to adapt to the changing universe, to survive the death of the stars and the cooling of the galaxies and the long dark era that follows. This is not impossible. It is not predicted by current physics, but it is not ruled out either. The future is long, and the laws of physics, while they constrain what is possible, do not specify what will happen within those constraints. The universe has surprised itself before, producing complexity where none was expected, producing observers where none were required. It may surprise itself again, but this is speculation. This is the hope that sits at the edge of the evidence, the possibility that the story is not as closed as the physics suggests. The physics suggests a closed story. The physics suggests a universe that is moving in a specific direction, governed by specific laws, heading toward a specific destination, and that destination is not hospitable to complexity or observers or memory. The physics suggests that the silence will win, not because the silence is stronger than the complexity, but because the complexity is temporary and the silence is not. The silence was here before the first star. It will be here after the last one. It is the universe's default state, its resting condition, the thing it returns to when the temporary interruptions have run their course. The stars are the interruption. The galaxies are the interruption. The living things are the interruption. The questions are the interruption. And the interruptions are ending slowly, on timescales that make the word slowly almost meaningless, but ending nonetheless, moving toward the completion of a process that began at the Big Bang and will finish at the heat death, and will leave behind a universe that is, in every meaningful sense, empty. Look up one more time. Look at the night sky with all of this in mind. Look at the stars and know what they are. Temporary nuclear furnaces, spending the universe's reserve of ordered energy, burning through their fuel at rates that range from millions to trillions of years, but burning through it nonetheless, moving toward the cold and the dark that wait at the end of every stellar life. Look at the darkness between the stars and know what it is, the dominant feature of the universe, the majority of its volume, the preview of its future. Look at the faint smear of the Milky Way and know what it is, one filament of the cosmic web, one thin thread of matter in a universe that is mostly void, one temporary concentration of structure in a cosmos that is moving toward uniformity. And look at the light. Look at the light that is reaching your eyes right now, that has been traveling through the emptiness of space for years or decades or centuries or millennia, that carries information about the state of stars that may no longer exist in the form they had when the light left them. That light is real. It is one of the most extraordinary things in the universe. Information traveling at the maximum speed the laws of physics permit, crossing the emptiness between stars, arriving at a surface where matter has organized itself into a form capable of receiving it and responding to it. That is happening right now. That is the universe doing something remarkable, in the brief window when remarkable things are possible, but the window is finite. The light will not always have a receiver. The stars will not always have an audience. The questions will not always have a questioner. The universe is moving steadily and without pause toward a state in which the light travels through a darkness that contains nothing capable of receiving it, in which the questions have no one to ask them, in which the remarkable things that happened in the brief interval between the Big Bang and the heat death are gone, not preserved, not remembered, not mourned, simply gone, as if they never happened, in a universe that has no way of knowing that they did. The emptiness is not coming. It is already here. It has always been here, in the voids between the galaxies, in the spaces between the stars, in the gaps between the atoms, in the silence between the questions. It is the universe's most honest self-description, the feature that persists when everything else has faded, the condition that was present before the first structure formed, and will remain after the last one dissolves. The emptiness is not the absence of the universe. It is the universe. The stars and the galaxies and the living things and the questions are the absence of the emptiness, brief and improbable and extraordinary, burning against a darkness that was always larger than they were and will outlast them by an interval so vast that the word outlast loses its meaning. You are one of the brief things. You are here, now, in the window, capable of knowing this. The universe does not know that you know. It does not care. It is expanding. It is cooling. It is moving in its direction, following its laws, heading toward its destination. And its destination is the silence that has always been waiting, patient and absolute. At the end of everything that has ever burned or moved or asked a question in the dark, the stars will go out, one by one over timescales that dwarf every measure of time that human civilization has ever used. They will exhaust their fuel and cool and go dark. The last one will go out without ceremony, without witness, without any structure in the universe capable of registering its passing. And after it is gone, the universe will continue, cold and dark and expanding, for a time so long that the era of the stars will seem, in retrospect, like a single brief flash of light in an otherwise unbroken darkness, a flash that happened once, that produced everything that has ever been called real, or beautiful, or meaningful, and that is now over. The darkness is not waiting for permission. It is already the majority. It has always been the majority, and it is patient in the way that only things without awareness can be patient, completely, permanently, without the possibility of impatience. It does not know it is waiting. It does not know anything. It simply is, as it has always been, as it will always be, the dominant feature of a universe that briefly, improbably, and perhaps uniquely, interrupted itself with light.